Good morning, everybody. I'm going to assume that it's morning for most of you. It's actually about 4 o'clock in the afternoon here for me. Thank you very much for coming along to my session this morning, especially because there's a lot of really great sessions and it's so easy to jump between the rooms at the moment. So, my name's Amy. I live in Perth, Australia, which means that I normally have to travel for at least 20 hours to get anywhere. And this time was no different. I mean, it took me almost a whole minute to get here today. It was mainly due to the fact that there was a dog in the middle of the hallway blocking my path. I'm really excited to get to speak at NDC Porto this year as well. Although I'm not a huge fan of the weather here at the moment, it pretty much feels like I could have just stayed in Perth. I mean, it's overcast, it's been raining off and on. Not a huge fan of the Porto weather right now. And although this may be the first session for you all this morning, I've somehow also managed to get a Friday afternoon slot again. So I'm based in Perth and I'm a freelance front-end developer, which means that I spend most of my time at the beach and the rest of it working from home in my pajamas. And technically, right now, not much is meant to have changed with how I'm working, although there's a lot less travel involved for me. I'm also very heavily involved in the Perth tech community. I help run a user group for front-end developers and the Perth Azure user group. I'm on the committee for DDD Perth, which is the largest tech conference in Perth. I attend pretty much all of the Perth tech meetups, and I work as an evangelist for YOW conferences, which is another tech conference based in Australia and New Zealand. Last year, I also became a Twilio champion and a Microsoft MVP. And in case you haven't already picked up, I have a beautiful grey and white border collie who normally sits next to me whenever I work from home. However, he has been put outside with treats so that he doesn't come and bother me while I'm giving my talk. He's also getting very confused about all of my video calls. Whenever I start a call and I say hello to the people on the other end, he can tell I'm talking to someone, so he'll instantly go to the front door because he assumes that there's someone coming to visit him. And this morning, I'm here to talk to you about accessibility. But rather than do what every other accessibility talk does, today I want to teach you how to make things less accessible. I'm also going to talk about a lot of the ARI attributes and roles that you might use in your applications. And I'm going to talk a bit about testing, some of the tools you can use for testing, and also how to decipher the warnings or errors that you get from tests that are running as part of your build pipeline. So starting off today, I want to talk about buttons. Very key part of most web applications. And as I go through a lot of these examples, I'm going to provide the links to these examples online. These are all in CodePen if you want to have a look later. I will also be sharing out all of these links at the end if you don't manage to get a hold of them. So here we have two buttons. We can click on the buttons, we can get the buttons to do things, but we can see when we're hovering over the buttons, when we click, things will happen. But one of these isn't actually a button. One of these is a div. This is something that I see in a lot of applications when rather than using a button, we will use a div and provide scripts to make it function as a button. Now, yes, you can do this. Yes, you can make a div work like a button, but do you really want to when you have to use significantly more code and more scripts to get something to do, something that's actually just included in the HTML? Buttons, by default, are keyboard accessible, which means anybody navigating around an application on their keyboard can access the button. they're clickable, they're tabbable, and they're focusable so that you know where you're sitting on an application. Divs don't have any of these things out of the box. Divs are literally just a container. The only thing that a div does is it will put a wrapper around whatever element's inside of it, and it sets display block to that element. That's all a div does. Although we can use scripts to do this, it is still less accessible, and it's also a lot harder for us to do. Next, I want to talk about labels, specifically labels in forms, and go through a couple of examples of different ways we use labels in forms. Now, this is an example I see a lot, which is no labels, because we have this really great attribute, which is the placeholder attribute. So rather than including a label and then having to do that, we can just include a placeholder to describe what that input is for. Now, these placeholders are really great because they display inside the input. It's nice and clean. It gives a professional look. We're able to still type in the field and the placeholder will disappear. And if we remove the text from the field, the placeholder will come back so we can see what was going on. Placeholders are amazing. This is really great. Why would we actually want to use labels if we can just use a placeholder? Because this may be what we see, but anybody using a screen reader has this announced for each of those fields. Let's edit. Edit, 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 which is fine if you're able to also have a look at the form. But if I hide those placeholders, does anybody remember what those fields were actually for? Not a great experience. So anybody who can't actually see what is going on with the form fields can't tell at all what any of these fields are meant to be. But I understand a lot of the time you may get a design that doesn't include labels, so you need to include the placeholders instead. The great thing is we can still include labels within our forms, but we can position them so that they're off the page. This means that a screen reader will still pick them up. Screen reader is able to read the label and it knows what the input is for, but it doesn't appear to any of the users. So we still have just the form inside of our browser window, and the labels are positioned off the page out of view of the users. So the screen reader can access them, but the users don't encounter them, which gives a much better experience. The screen reader will still continue to announce edit, but it will also give context around the label attached to the input. If you wanted to, you can go a step further, which is to position the label as though it's a placeholder and to move it out of the way once somebody starts to type. This allows a label to stay there. You can still see the label when you've started to type within the field, but it has a clean, empty form feel. Now, you can do this by adding an event listener to each of the inputs. So here we're using JavaScript to query for all of the inputs within a form. For each of them, we're adding an event listener. We're checking for if there's any input. We're checking for the, so here we're checking for any input. That's the event we're checking for. So if anybody's typing anything inside the field. If they type anything inside of the field, we're then checking whether or not that field now has a value, and we're going to make sure that value isn't an empty string. If the field now has a value and that value isn't an empty string, we're then going to add a class to that input to let us know that something's been typed in it. Sorry, we're not actually adding the class to our element. So we're getting, here's the element, which is being typed in. This is the input being typed in. We're then going to go up the HTML, the DOM tree, and we're checking for the previous sibling. And we're going to add a class list to that. So the previous sibling, we know in our form is going to be a label. And so we're going to add the class to the label. There would be different ways that you can do this, and it may work a little bit easier, but this is the example that I've included today. All I then have to do is use CSS to position the label so that it sits over the form input, and if it has the class active, to move it back up. And I can also include a transition so that you can see it moving rather than it just flashing between the two of them. Next, I want to talk about icon labels. So we often see them in social menus, social navigation menus, rather than include the names of the different platforms that we're linking through. We can just include the icon and people can access it that way. So we would see it somewhere like this with a list of different social profiles, my CodePen and my Twitter and my website, and include maybe an image or an SVG icon for each of these. Now this is great, except for when someone uses a screen reader, they have announced link, 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 link. And again, if they can't see what that icon is, that doesn't provide much context to what you're actually linking to. And as we've all probably learned at some point, don't click on a link if you don't know where it goes. That doesn't seem very trustworthy. So similarly to our form input, we can actually include a label and then make it position of the page. So here I've included a label for each of my links inside of a span element. Including it inside a separate element makes it really easy for me to style it and position it. So I include the label for each of my links and then use CSS to position those off the edge of my page, which means that now when I go through and the screen reader has a look at each of my links, it's able to read the text that's in my span and provide more context around where I'm linking to, but that's not appearing on the page. So they're off the edge of the page. Next, I want to talk about hover effects. Now, hover effects are the kind of things that we see when hovering over links or buttons or an element that we may be able to interact with. This is often done by changing color to signify that there's something you can do with it. When I hover over the link, I change the color to let people know that they can click on it. As we can see here, the color is changing on hover, which means I must be able to do something, probably click on it. Now this is great, but what happens when what happens if a user has a vision deficiency and is unable to differentiate between the two colors you're using? Can you tell the difference between the colors here? You might be able to just a little bit, but it's still incredibly difficult. Using something like a color change leads to difficulties if someone has various different vision deficiencies. So rather than that, we can use a different hover effect, changing the background, adding a border, or changing the underline on the text. It means we're not just relying on differentiating between color. This means that if somebody is unable to tell the difference between two different colors, they're still able to see the hover effect that we see here. Now, a lot of people often ask, well, there's such a small percentage of people, and here I've used an example of a very, very extreme vision deficiency. And there's such a small percentage of people who are impacted by this kind of thing. So it's not just around permanent impairments. I have a feature on my phone. Anybody here have an Android phone? I have a feature on my Android phone which helps. It's meant to help me take time away from technology, and now I'm not doing great with that because technology is the only way I can talk to people. It's I forget. It's not do not disturb. What it does is it will, similar to how you can change the brightness on your screen as it gets later in the evening so that it doesn't affect your eyes as much. It will automatically turn on grayscale on my screen on my phone to let me know that it's time to go to bed and I should be putting my phone down and stepping away and getting ready for bed. And I didn't think too much about it until I was having a look at somewhere. I was moving house and I was having a look at an application by a company called Domain, which is an Australian real estate company. So I was having a look on the map and they had little pins for each of the houses that I was looking at. And once you've looked at a property, it will change the pin from green to red to let you know that you've looked at it. And it wasn't until my phone turned grayscale on that evening that I realized I can't tell the difference between green and red. So even though I have great vision and I don't have a color a form of color blindness, this is still something that affects me when people are only using color to differentiate between two different states. Next, I want to talk about tab index. Now, tab index is a property you can apply to dictate the order of elements that will be tabbed when someone is navigating by tabbing through when somebody's tabbing through your website, the order that the elements will be selected. This is often used in things like forms. Now, for someone who hasn't worked with tab index before, this is a quick breakdown of what the different properties you can give it are. So a tab index of 0 means that the element can be navigated to via a keyboard. This is something we often use if you want people to be able to access an element that you wouldn't normally. For example, if you've made a div a button and you want people to be able to access it via the keyboard, giving it a tab index of 0 puts it in the running to be accessed via a keyboard user. A tab index of -1 says that it can't be navigated to via a keyboard. This isn't something that you can interact with. And a positive tab index, for example, a tab index of 1, 2, 5, 10, will dictate the order that elements will be interacted with. For example, if I have a form and I number each of my inputs, 1, 2, 3, 4, and 5, when somebody tabs through it, these will be highlighted in the order, starting at 1 and finishing at 5. This means you can dictate the order that the fields will be interacted with if somebody is using their keyboard. Now, this is really great because you get control over how people are accessing things. But what happens when you have to add a new input into your field and you may not remember about the tab index, or maybe another developer who doesn't add it? And you then have a field that isn't in the order dictated. This means that anybody who's using a keyboard to navigate through your application is going to have a fairly poor experience because the form isn't working the way they expect it to. Now, this is something I have seen many, many times as a user, just trying to fill in a form where people have tried to include the tab index. So unless you actually need to change this, this is something that we probably shouldn't be using. Next, I want to talk about ARIA attributes. Now, ARIA is something that often grabbed for when you're working on a project where you know accessibility is very important, but most of the time they're not actually necessary. Earlier this year, I was working on a project that needed to be accessible, it needed to conform to a certain requirement. And a developer I was working with ran a testing tool which told him to add roles to the various elements on the page. Now, role is an attribute that you can add, and there's a heap of different roles that you can assign. This is a few of them that I've included from the page, things like button, checkbox, slider, article, heading, complementary, banner, navigation, whole heap of them. There's a list on the Mozilla Dev Docs if you really want to have a look at all of the roles that are available. But he was having a look through, and we had one of those sections which had a bit of text and it had an image, very nice looking. And he went, well, this has the role of presentation because this is a very visual point. And so he added the role of presentation to the element. Now, I then went through and ran a different testing tool, and it flagged an error. Because what the role of presentation had done was it let a screen reader know that everything inside of this element is just for visual effect only. So it doesn't actually provide any context. There's no element you need to interact with. So it just ignored the whole thing, despite the fact that there was actually stuff to do inside of it, like a link you could click on. What we could have done instead was only singling out the image, which was visual, and including an empty alt tag, which lets a screen reader know that this image is just for visual effect and does not provide any additional information or context to the user. So it ignores it. Alt text is the attribute to define an alternative text description of the image. So if you do actually have an image that's important for people to look at, for example, a graph or a figure, you can describe it in the alt text. But for a lot of the images that we see on websites, they don't provide any additional context. And so this lets screen readers know they don't need to worry about them. Now, the secret with a lot of ARIA stuff is that semantic HTML actually negates the need to use these labels and roles. And I found a really great section on the Mozilla Dev website reminding us that many of these were later incorporated into HTML5, and we should use the correct semantic HTML element over using ARIA if that element exists. For example, we don't need to use the role of button because we can just use a button, which infers that it's a button. We don't need to use the role of form. We have a form. We don't need to use the role of navigation because we have a navigational element. So making sure that we're using proper semantic HTML goes a really, really long way with making our websites more accessible. Another one that I see a lot of is ARIA labels. Now, ARIA labels allows us to label a current element, and it's used to describe when there isn't text to describe it. For example, if we're using a bunch of icons in a navigation menu, we could add an ARIA label to each of the icons to describe what it is. We could add the ARIA label there to let the users know what it is that they're clicking on. However, as ARIA label is a HTML attribute, it doesn't get included when a browser is used to automatically translate content on a page. So have you ever gone to a website and it's in a language you can't read, and so you use Chrome or your browser to translate the page? Anybody ever done that before? Trying to make sure no one's falling asleep because the coffee hasn't kicked in yet. This is the first time I've done a remote presentation where I can actually see faces. So it is nice to just sort of see people at the corner of my eye. And if anybody did fall asleep, it would not be the first time somebody has fallen asleep in one of my presentations. Only this time it's not somebody in the second row. It's actually somebody who's just gotten up and sitting at home on their couch. So ARIA labels aren't included when we go through and translate content on a web page, which means if I write my ARIA label in English and someone tries to translate my web page to Portuguese, they won't know what the label is because that label hasn't been translated. However, we can use ARIA labeled by to do this, which allows us to define text content elsewhere, and that is used to describe a particular element. Now, this works fairly similarly to how we link a label and an input. The difference is with ARIA labeled by, we link the content to the label, whereas with inputs and labels, we link the label to the input. So you can use ARIA labeled by, and if a user tries to translate your web page, they will get the label content translated as well. Okay. Next, I want to talk about testing. Because although we're all going to go away from this today and make sure that we're writing more accessible code, we're going to make sure our forms have labels. I was helping teach a workshop the other week, and one of the other mentors went through and wrote a form for everybody that had no labels. Had to stop him and get him to make sure it had labels in it. Although we're going to make sure that we're writing accessible code, a lot of the time we're working in big teams of other developers, or it may even have been code that we wrote at 2 o'clock in the morning 3 years ago and we had no idea what was going on there. There are a heap of different tests that we can do to make sure that our code is still accessible. I want to add a disclaimer that although there are several automated tests, and there are a bunch of tools that you can use, to properly test for accessibility, you need to use user testing. You need to have this testing done by somebody who's using the assistive technologies every day. There's a huge difference between when I open up a screen reader to test something on my computer and someone who uses it as the only way to navigate the internet every single day. So if this is something that your work, your company is really taking seriously, see if you can get somebody to come in and run proper user testing to make sure it works. In the meantime, we can run a bunch of different testing tools over the application to get a lot of the little things. Now, one of the tools that I really like is a tool called Pally. Pally is open source. It has a few different versions, but I really like the command line version because it's something I can include in my build process. I can run it automatically and it just does stuff. And I can also log all of the test results within my Git repository so I can track improvements over time. Now, Pally runs tests against the Web Content Accessibility Guidelines, or WCAG, and you can find a full list of the guidelines on the W3C Web Accessibility Initiative, the W3C Way webpage for the WCAG guidelines, one of those acronyms. They have a full list of the guidelines, but the great thing about Pally is it will actually check your application against all of these guidelines, and it just tells you the ones that you need to look at. Because unfortunately, the accessibility guidelines aren't very accessible for people to read. Even if you work in accessibility, they're a little bit difficult to deal with. And now I'm going to do a demo with Pally, which we're going to hope works. So now here is one that I've prepared earlier. So Pally is used, so I've included it in my project, which I'll show my project first. My project is a blog because I can never decide what kind of application to use on a demo. So I have a blog that I'm running tests on. Now I've included Pally in my project. So it's one of the packages that I've installed because there's no way I'm going to try and install it while still running an online web call. Now, apologies if anybody here hasn't used JavaScript before. Pally writes its tests in JavaScript, so this may be a little bit foreign to you. I'm including the Pally package. Now, Pally also uses Puppeteer to run its tests. Puppeteer is a way to use it's a way to virtually run tests in a browser without actually opening the browser, if that makes sense. So I'm using I'm requiring the Puppeteer package so that I can do that. And I'm also requiring an additional package which allows me to save a file when I'm done. I've defined a function here for my test. And in that, I've defined a couple of the details that I'm going to use to run my test. Now, the first one is I've defined some custom settings for the Puppeteer browser. This is because I run a Windows computer, but I use WSL, which is the Windows subsystem of Linux, which means my computer gets confused because it thinks it's on a Linux machine, but it's actually on Windows. So when I try and run this on the command line, it tries to open the browser where it knows it would be stored on a Linux machine and gets really confused. So this is a hack to get it to work in WSL. Great thing is I've done all of the research, so I know how it works now. Then I'm also defining, I'm going to run a bunch of tests. I've set it up to do promise all, which means that it will go through and run multiple tests, one after another, which is good because it means I only have to do it through the one function. Now, the first thing I do inside of the Pally function is I'm pulling in my site URL from up here. I want it to visit the page of one of my blog posts, and I want to check that. I'm using the browser variable that I've defined at the top so that runs properly. I'm then also going to define the WCAG standard that I want to test it against. And I want to test it against the AAA standard, which is the top tier. So I want to make sure my blog is super accessible to everybody. One of the other features that I use within Pally is I'm also going to go through and save a screenshot of my application when it runs the test. Now, this is really useful because you're using a headless browser, it may render the application differently to how you expect it. And so saving a screenshot means that I can see exactly what Pally did. This is really useful for if you get a weird result or something that you weren't expecting, you can see exactly what it looked like. I'm then defining another test. I'm going to save a screenshot for that as well. And for this one, I'm also going to define the viewport. And I'm going to set a small viewport because this one I want to test the mobile screen size. And I can also define that it is mobile, so it tests against those kind of devices as well. And then I also want to do another test, again, also against the home page, but this time I'm testing against a desktop screen size. At the end, I take all of the results that I've gotten and I'm going to write them to a file, which I'm saving inside of my test results folder. And so it will give me a JSON string. And if I get an error, I want it to log out the error. Now, if I can get my terminal up, which is currently hiding behind everybody's faces, I think. No. Open up my terminal. That is still hiding behind everyone's faces. Okay. So I'm going to open up my terminal and move into inside my project folder. And I've already set up a script to run this, but I can just run it with Node. And so using Node to run the file inside my test folder, I'm going to get the pali.js file, which is the file I've written my test in. And I'm going to go through and run that. And what that will do is that will then load my web page inside of the Puppeteer browser, and it will run various different tests against the guidelines for the AAA specification that I've set. And it's now done. It's now finished running the tests. And I can find those tests here in a lovely big JSON document. There we go. That's a lot of issues for my application. Okay, so we can go through and have a look at a lot of the issues that I've got here. So here says the title element in the head section should be non-empty. So this is really great because it will give me a lot of information about the issue that I'm getting. So here it's given the particular guideline code that it's found an error with, whether or not it's just an error or a warning, the message that it's given, which the title shouldn't be empty. Well, the title should be non-empty. It provides information about the HTML element that it's had issues with, which is a title that we can see is empty. I haven't set a title there. Also, the selector to make it easier to find where exactly that element is. So no inside HTML, inside head, inside title. So it includes a lot of information that I need to have a look at in my application. If I needed to find more context around this guideline as well, I can have a look. So this is the particular guideline that it's flagged. And if I find, this is a list of all of the WCAG guidelines. And if I search for the guideline that it flagged, I can find that here. So this is the section, and this is the guideline that it's had issues with. The title element in the head should be non-empty. So that's really great for finding more information about what the actual issue is and what you should be doing to fix it. Although this one's fairly obvious, I need to set a title in my head section, which we do it now so that it's done. That is not what I was after. Yeah, that's where it'll be. Yeah, there we go. So if you have a look there, I'm not getting a title. So I can change that to be my testing blog. And now if I run my testing again, that issue should be fixed now. And wait for it to finish. There we go. So now if I have a look at my test again, I no longer have the error about the title attribute. Instead, I have a bunch of different errors about contrast. which I want to have a look at later. So there's a bunch of different ways that you can provide the Pally results as well. So I recommend having a look at their website if you'd like to use it. You can give a nice, easy to read HTML report. You can format it to do exactly what you want. Awesome. Demo worked. Now, before we wrap up, I want to give a bit of information on deciphering some of these test results that you might get. A lot of the time, they are fairly straightforward, like title should not be empty, but sometimes they can be a little bit confusing, or may suggest that you need to do things that you don't need to. So it's important to understand the principles that you're trying to fix. Otherwise, you might end up putting role presentation on an element that actually has really important content. So this is one that we get a lot of: image element missing an alt attribute. Use the alt attribute to specify a short text alternative. Now, this happens a lot, particularly when you're pulling in images from somewhere else or dynamically generating content. We may not have the ability to go through and define an alt attribute for each element. Now, one thing that we need to remember with this, which we've already touched on, is not actually everything needs an alt attribute, but we don't have to write a short text alternative. If your image is only meant to be used to add a visual effect, if it's a nice pretty picture or background, something that doesn't provide additional information to the users, then it's okay for it to not include an alt attribute. An alt text alternative. All we need to do is just provide an empty alt tag, so alt with just 2 quotes. That will let the screen reader know that it doesn't need to worry about the image. If we don't include an alt text alternative, what the screen reader goes through and does is it reads out the path of the image, which this person isn't too bad because I've named my image nicely and it's a fairly short path. But if you have a think about some of the paths to images in your applications, you don't want somebody to have that read out to them because you can't stop it once the screen reader gets started on that. Another one which we saw in my application is this element has insufficient contrast at this conformance level. Expected a contrast ratio of 4.5 to 1, and the text in this element has a contrast ratio of not a number to 1. So this is an error that I get a lot because it's having issues comparing the contrast ratio. So if we have a quick look at one of the places that I have this, we have a look. Okay. HTML body header H1A. So, there we go. So that would be here. Now, okay, that could have an issue. See if I can find a different one that I know definitely doesn't have an issue. Time. Okay, so I'm getting an error about this one here where I have the date. It said that the date has insufficient contrast with what's going on behind it. And if I have a look, so it's really great to have a look at the developer tools. Most of the browsers now have accessibility contrast checkers built into the tools. So if I have a look here where the date is, I can see this is the color. It actually has a contrast checker in here. And so it has a look and compares it. So this is the color, this is the background of the element behind it. And it said that this has a contrast ratio of 16.42, which definitely meets the AAA requirements because that says I need to have at least 7. So this is really great for going through and checking to make sure. So it's important to make sure that we're validating, because a lot of these errors are more the fact that we have a tool running in the command line that's trying to test against a visual thing. So that one's a little bit hard to check against. An important one to know as well, if it's probably not an issue, see this here where it says it's not a number? Probably means something has gone wrong. Something has broken there. Another one that I see a lot of is this one. This form does not contain a submit button. So we get this happen a lot in things like search forms and newsletter signups because they're nice and small and it's one field and we can just hit enter to submit it. But the problem is we then don't have a submit button. So again, similar to the labels, making sure that we're including a submit button, and then we can position that off the page. So it's still there and it's still something that keyboard users can interact with, but it doesn't have to visually appear on the page. Alternatively, there is ways that you can style the submit button so it's still one small field that people can use. Now, one of the other tools that you can use for testing is Axe, which is a very, very widely used accessibility testing tool. They have a heap of different extensions and plugins that you can use. For example, there's React Axe for integrating with a React application. They also have a browser extension that you can use on Chrome and on Edge now that that's on Chrome as well. So you can run tests that way. A couple of other tools I really like using, this one, Who Can Use, which is a color contrast checker, but as well as testing the contrast ratio between two colors, it also then works out what the contrast would look like to people with various color deficiencies. So that one is really great to have a look at to make sure there's still contrast ratio for everybody. So Who Can Use is really great. It was actually built by a Perth developer. Accessible brand colors is another great one, maybe worth giving to your designers at work. This is really useful for putting in all of your brand colors and it will compare each of them against one another. So you can see what color combinations you can use, both the text and background colors, and you can single out which ones work and which ones don't. So that one's really great for making sure that designers don't send through something that doesn't quite pass the color contrast standards. Another really great package is the color blindness emulator, which I actually used in my presentation when I was simulating the grayscale. So it provides a SVG filter, which you can use to simulate the different kinds of color blindness. Really easy to use. Include the SVG file in your project and then just use CSS to set it as a filter over the element using the relevant filter to what it is that you're wanting to test. That's a good one to have a look at. If you're wanting to do some more stuff with testing accessibility, there's a really great blog post by me that I wrote Christmas last year, 12 Days of Front-End Testing. In it, I list a couple of accessibility testing concepts and as well as a bunch of different tools, and it's Christmas themed. So it's probably not the right time of year now, but hopefully you might get a giggle out of it. I also wrote a blog post back in January for JavaScript January, which was getting started with front-end testing. And the first part of it was going through running the accessibility tests, which I did here today. I also did my talk about front-end testing at NDC London back in January, back when we were allowed to see people in person. And that is now online if you would like to test out a little bit more about accessibility testing and see me try and do a demo and have it not work. If you're looking for something to try and make your application a little bit more accessible, there's a great set of accessible components at Inclusive Components. There's a bunch of them that are available free on the website. It's by Hayden Pickering. Otherwise, there is also a ebook or a physical book. I think it's in the living room. I have the physical book. It's a really nice book. A lot of really great components going through things like accordions and tab sections and sliders and the various things we have to build in our day-to-day, but providing us with code to make sure that they're fully accessible to everybody, which is awesome. The examples that I included in my talk today, I have a collection of them in my CodePen, which the link is there, and I'll also include the link in my slides at the end of the day. So that includes a lot of the different examples if you want to have a look at my code again or have a play around with it yourself. Now, normally I would say you can find me around the rest of the conference. I will be sticking around on the Slack for a little bit. I'm endeavoring to make it to the party tonight. We're gonna be playing Remote Exploding Kittens. If anybody wants to join, we'll be talking about that in the hashtag NDC Party channel. If you can't catch me on Slack, if I do fall asleep because it's really late here, you can find me on the internet. I'm mostly on Twitter. You can also find my website. I occasionally write things on blogs, not as much as I should. You can find links to my talks, my GitHub, and because I'm starved for physical and human interaction right now, I've also started streaming on Twitch. So after the conference, if you would like to get back into watching people make idiots of themselves on the internet, you can tune in. I occasionally stream stuff on Twitch writing code. Thank you very much for listening to me this morning. Hopefully the coffee has kicked in. Hopefully I haven't had the second person fall asleep in one of my talks. I think we do have a bit of time if anybody who's in the WebEx would like to ask a question, either in the chat or if you would like to unmute yourself and ask a question. We've got a bit of time for that. Otherwise, I will chat to you on Slack or the internet, or maybe one day and soon we will be allowed out of our houses and we can see each other in person. Any questions?
Yeah.
Yeah.
I was wondering if there is a tool for test Android and or iOS apps as you did for web.
Yes, there would be. It depends what you're testing. I actually have a feeling. I saw something with this morning. Yes. So Axe, which I went through, Axe have accessibility library for Android. So you would be able to use that to do testing with it. I do know they also have the screen read. I think it's TalkBack on Android, but I might be wrong. So you can test that out for testing screen readers. Other than that, I'm not too sure. Unfortunately, I haven't done much with native applications, but I do know people who have. So if you get in touch with me on Slack or on Twitter, I can find out and get you some resources for that one.
Just another one, sorry. We are talking about visual special needs, but there's another different needs that we should be aware.
Yes. Yes. So today, I should have mentioned at the start, most of the stuff that I looked at today was more around visual impairments, although sometimes a lot of so being able to navigate stuff by keyboard comes with a few other impairments as well. I'm trying to remember ones off the top of my head. Visual, making sure, so then you've got hearing impairments, so making sure if you have anything like a video playing, having a written, a captioned version available for people. Trying to think what else. Making sure you're not doing anything funky with your website. So things like sliders, a lot of the things that look really cool, you know, the flashy bits and the nice effects and stuff like that. That kind of thing can have issues for people. Can cause issues for people as well. So trying not to do anything too fancy. The other thing that's a big one is mobility impairments. So making sure that it's really easy for people to click on things. That includes things like when particularly, so you build for mobile. So making sure that people have a decent size to click on something and then accidentally click on something else. So this doesn't even just come down to someone with mobility impairments. This comes down to someone with big fingers trying to use a smartphone. So making sure that they have plenty of room for tapping on the right things as well.
Thanks.
Yeah.
Hi, can I add something, please?
Yeah.
First of all, thank you, Amy. It was a really great talk and I learned a lot. I have a question for you on a website. But first of all, I want to respond to Tiago on his question. Get in touch with me via Slack. As Amy does know, I did a lot of talks, a lot of talks on accessibility mobile apps, accessible mobile apps in Xamarin. But also, it's not only the Xamarin coding language; it's also about accessible principles for mobile apps. I focus most of the disabilities like blindness and so, but my biggest expertise is people with learning disabilities and autism, and so I also have a great advice for that. I also spoke at a few NDCs. Oh my God, and you're showing it, yeah, of course. I also spoke at a few NDCs in the past, and I speak at London at NDC Oslo, which is another talk. So if you look at me, I think, yeah, search me on the YouTube on NDC, you find way too much about my accessibility insight on intellectual disability. So that was for you. A question for Amy. From
Yep.
my own website for my business, my blog, and also my business and resource, we changed to WordPress because it's way easier to manage. Even I can develop .NET and so, but it's really more easy to manage. And I have a question on, are there plugins or assets in WordPress to make more accessible buttons to just WordPress and accessibility? That's my first question. I asked some two first, but then you can make an answer. And my second question is, I learned about Aria. I also heard it before. I'm not a big fan of JavaScript. Are there accessible things like Aria already for Blazor? Or is there a pipeline or other possibilities with Blazor? So WordPress and Blazor are my questions. Thank you.
Yeah. So Pally, which I use for testing. So I'll start with that one. So Pally, which I use for testing, it technically isn't. So you write the test in JavaScript, but it does work on anything. So all you have to do is give it a web page. So unfortunately, yes, you do need to know JavaScript to write the tests, but you can run it against any web page. They do have a few other different examples that you may be able to use, which it may be worth having a look at. Unfortunately for WordPress, I do actually do a fair bit of WordPress development, but I haven't done any. I kind of have things in two boxes. I have my business stuff, which is where I do WordPress development, and then I have my community and my speaker stuff, which is where I don't use WordPress. So unfortunately, I don't know anything off the top of my head. I can have a look and let you know though, because I'm sure there's something out there. There's a plugin for everything. However, in saying that, a lot of the new WordPress editor Gutenberg, a lot of the stuff that it creates is fairly accessible. Unfortunately, the editor itself is not great. That is really interesting about WordPress and accessibility, though. So I might have a look at it. And if not, I know a few developers who do a bit more stuff, so they may have encountered something there. Was that all of the
Thank you. Yeah, I'm happy with this question.
Yeah, no, it's good to see you again, Denny, at least through the computer. Denny and I have run into each other at a few of the conferences now, so it's nice to have a familiar face in my audience today.
And I will be at NDC Oslo too. And you too, I saw on the internet?
Yes. I will be giving this talk again at Oslo. Well, not at. I can't work out whether I still say at if I haven't gone anywhere to a conference.
Yeah, I call it at because virtual, you have to leave it as fully as possible. I call it at, but it's a better of a name. I'm doing not a brand new talk, but it's the NDC talk. I did the talk at another conference in real life this year in Finland, but not in NDC. But the NDC talk of a brand new talk for me, so maybe see you there also in my audience.
That'll be
brand new at Oslo.
That'll be cool. I'm looking forward to it. Yeah.
Thank you.
Anybody else have any questions? Nope, no questions. Well, it was lovely to have the chance to chat with you all today. Hopefully, I'll see you around at some point. And yeah, if you have any more questions, just get in touch. Thank you.
Thanks.
Thanks.
I stopped sharing my screen there.
Hello, everyone. This is the talk called Lazy Programmer's Guide to Writing Thousands of Tests. It's about property-based testing. If you're not a lazy programmer, maybe this talk will not be of interest to you. But like most people, I am in fact a lazy programmer. So I don't want to write lots of code if I don't have to. And property-based testing is one way to avoid doing that. So my name is Scott Voloshin. And where is it? There we go. Scott Voloshin, fsharpfunandprofit.com. So the examples in this talk will be kind of F# code, but the language is not really important. It's the concepts that are important, and these concepts apply to pretty much any programming language. So here we are. The NDC community, unfortunately, is social distancing. So I'm working from home like you are. Hopefully we can all stay safe and still have some fun. Right. So in order to set this up, I'm going to tell you a story. It's a semi-made up story. Part of it's true and part of it isn't. I kind of exaggerated. But I mean, I was working with a remote developer a long time ago in a galaxy far, far away. And for the benefit of the story, I'm just going to say that we needed a function that would add two numbers together. Okay, it was more complicated in reality, but there we go. How do you add two numbers together? And so the remote developer says, sure, I've just finished adding the add function. I'm happy. And I say, have you written unit tests? And they say, you want unit tests as well? Yeah, okay. They kind of sounded surprised. So they wrote a test. Given inputs of 1 and 3, I would expect the output is 4. That was their unit test. And then they say, okay, can we call it done? And I would say, well, actually, that's only one test. How do you know it doesn't fail for other inputs? It's just like 1 and 3. So they say, okay, let me write another unit test. And they said, okay, I just wrote another awesome unit test. They thought they were, a certain kind of developer who said that kind of thing. 2 and 2 is 4. And that's an awesome unit test. And I wasn't so impressed. I said, you're testing for special cases. How do you know it doesn't fail for other tests that you haven't thought of? And he was like, you want more tests? I've already written 2. Well, how much do you want? And that is a good question. How do you know that you have written enough tests? And this is quite a deep question. How do you know that you have enough tests? Is 2 tests enough? 5 tests? 100 tests? The whole point of testing is to gain confidence in the implementation. And you can have 100% test coverage and still have, bad implementation. And you can have, a small test coverage, but still have very high confidence in the implementation. And so that's one of the things that we're going to try and talk about. So in this case, I didn't trust this person to write unit tests. So I thought I'd write them myself. So I had a look at the existing tests. This is F# code here. When I add 1 and 3, I expect 4. And I do the add function, and I assert that the answer is 4. And that passed, okay? And then let me write another test. If 2 and 2, and I call the add function, and I expect the answer to be 4. Okay, so that's good. That one passed the test. So let me write a test, okay? So when I add -1 and 3, let me do something tricky. I add -1 and 3, and I would expect the answer to be 2. And this test failed. So I thought, okay, well, that's kind of funny. Let me go and look at the implementation. Let's just check and see how everything is. So here's the implementation. To add two numbers together, return 4. Okay, and in F# you don't need a return keyword. So that was the entire implementation. And I was like, what is this? This is terrible. So I wrote back and I said, I'm going to write the tests and you're going to make them pass, okay? I don't trust him. And he said, sure, no worries. So let me write some more tests. I'm going to 2 and 3, I expect 5. And he wrote his implementation, passed that, okay. And then if I do, let's say 1 and 41, I'd expect 42. And that test also passed. So okay, maybe his implementation is getting better. So let me just check the implementation though, just to be sure. So this is the implementation. And if the input is 2 and 3, the answer is 5. And if the input is 1 and 41, the answer is 42. And in all other cases, the answer is 4. And, like, this is not a very good implementation. This is not a very good implementation. And I'm saying, so I said, what are you even doing? You haven't even implemented anything yet. You've just made the test pass. And he said, chill out. I'm totally following TDD best practices, which is you write only enough code to make the failing unit test pass. And that's exactly what he was doing. And, I think that's, I'm not sure that's quite what they meant when they said that. But, he's following it literally. Okay, so I thought, well, let me just try and make it more complicated. I'm going to have a whole set of test data, a whole array of test data, and for each answer in the array, I'm going to see if the actual answer matches the expected answer. And that passed. And I had a look at implementation again, and of course, you can guess what he did. Basically, every possible thing that was in the input was hard-coded. So we have a problem. Houston, we have a problem here. It dawned on me that I was dealing with a certain kind of person, the legendary burned-out, lazy, malicious programmer called the enterprise developer from hell. And you might have, in your life of developer, you've probably met people like this. They are lazy and they're also malicious, and they also are not, sometimes they just try and make life worse for everybody else. So, and I've used the evil Garfield as the symbol for this person. So I've got to rethink my approach. The enterprise developer from hell will always make specific examples pass, no matter what I do. So what can I do? I have to not use specific examples. But how can I write a test without having any examples of what I want? Okay, so let's use random numbers. So this way he can't guess what they are. So I take a random integer and another random integer, and I put down the expected answer, and I put the actual answer that I got from calling this function, and I check that the answers are equal. And this is fantastic. Let me just do it 100 times, just in case he gets lucky with the two random numbers. So I'm going to do it 100 times, just so it's not a coincidence. Okay, so there's the final test. 100 times, take two random integers, add them together, and make sure that when we call our new add function, that they get the same answer. So this is great. This is great. The enterprise developer from hell cannot possibly beat this this test. However, we have a bit of a problem because I have basically re-implemented, I'm using the built-in addition function. And if it was a brand new kind of functionality, I'd have to re-implement the functionality in the test to check whether I got the right answer. And this is a really common problem in testing, is you basically have to re-implement what you want in order to test it. And that's, that's an anti-pattern. You do not want to be re-implementing things to check that they work. So this is a problem. So how can we fix this? How can we fix the problem of implementing add without using the add function? All right. So if we can't test it by comparing it with something we already know, how can we test it? So how would you write, this is a question for everyone listening, how would you write a test for an add function without re-implementing add or without using any of the built-in libraries and without using any specific examples, like 2 + 2 = 4. So that's the challenge. And this leads us to property-based testing. So in order to implement it, we need to know what the requirements are. And what are the requirements for the add function? It's hard to know to get started with these things, but one way is to think about, if you don't know what the right answer is, you could often compare it with the wrong answer. So we don't know what add should do, but we know that addition is different from subtraction. How does addition differ from subtraction? Well, one simple thing is that the parameter order makes difference. So in addition, it doesn't matter which order the parameters are, but subtraction, it does, 5 - 2 is not the same as 2 - 5. So we could write a test for that. Okay, so that's a little difference we can write a test for. So here's our test that checks that little thing. So we say that whatever the thing is, it doesn't depend on parameter order. So we take we do what we did before. We take 100 different random numbers, and we add them together. And we also add them together with the parameters reversed. Okay, and then we check that we have the same answer. And if we do have the same answer, you know, it's a quite a good test. It's not 100% perfect, but it certainly eliminates the wrong answer of subtraction. Okay, so a whole bunch of incorrect implementations have been eliminated this way. Now, of course, the enterprise developer from hell is clever and they're evil, and they will respond with this implementation. To add two numbers together, you multiply them. Now, this passes the test. He's particularly easy. He's being very, very evil today. Unfortunately, this test passes with this bad implementation. But we're getting the hang of it here. We can keep doing the same thing. So what's the difference between addition and multiplication? Well, that's a bit trickier, but you know, a simple one is if you add 1 and you do it twice, that's the same as adding 2. But if you multiply by 1 twice, that's not the same as multiplying by 2. So let's turn that into a test as well. We're going to call it 2 adding 1s. 2 of adding 1s is the same as 1 add 2. So here we go. So again, we'll take our random number. We'll add 1 and we'll add 1 again. And the second one is we'll add 2. And they should be the same answer. Now this will eliminate the multiplication implementation. So that passes. But the enterprise developer then says, okay, I'm going to implement this with minus y, with subtraction. And this passes the test because subtracting 1 twice is the same as subtracting 2. So when I try and do this test will now pass with subtraction as the implementation. But we have the previous test as well. So when I add two numbers, the number that doesn't depend on parameter order. So the previous test now fails. So the combination of these two tests is what narrows it down. Each individual test eliminates a set of things, and when you combine the two tests, they really start narrowing it down a lot. So can the enterprise developer from hell come up with a test that implementation that will fail? Let's see. But yes, he can. And this is his implementation. To add two numbers together, you return 0. And actually, this passes all the tests because you know, doing it twice, that passes, and it doesn't depend on the parameter order, that passes. So, okay, how can we write another kind of test that eliminates this kind of implementation? And the problem is that we're not, we haven't really understood addition, because there is somehow the addition function is the output has to be connected to the input somehow, right? And it does depend on the input, but we don't want to have. We don't always know how it depends on the input because without actually re-implementing it. But is there a trivial input that we do know the answer to, like without having to re-implement anything? Is there an input of add that we always know what the answer will be? And the answer is yes. If you add 0 to something, that's the same as doing nothing. So let's write a test for that. Okay, so we're going to take do it for 100 times to do a random integer. We're going to add 0 to it, and then we're also going to have the original number, and they should be the same. I should be untouched. So if we add this extra test to it, this actually will pretty much defeat the enterprise developer from hell. We have this test, we have this test, and we have this test. And if you combine these three tests together, any particular implementation will be much harder to. It's much harder to have a sneaky thing. In fact, this is not 100% perfect. I mean, this is pretty true. There is actually one way of making this fail, but we can extend this idea to make it so it's literally impossible to fail. So that's the idea of property-based testing. We're not testing individual examples. We're testing properties of the function, the fact that it's independent of parameter order, That's a property of the function. No matter what the inputs are, it's always true. It's a invariant of the function. Adding 0 is the same as doing nothing. That's always true, no matter what number you have as input. So without using specific examples, we've narrowed down the implementation of add. So let's refactor this out. Let's extract the shared code. We've got a lot of common code here. So what we're going to do is write a method or a function called property check, and it has a parameter, which is the property function. This is what we're going to be passing in. And in this particular case, the property function takes a pair of integers as input and returns a Boolean as output. It always returns true or false. And so our generic property function looks like this. We take a random integer, we take another random integer, and we call this property function with these two integers, and the result is either true or false. Okay, and we always want the result to be true. This property should always be true. And if it is always true, then we have a good idea that the property passes. Okay, so this property function, technically it's a function. We just generally call it a property. It's like something that's always true for a set of inputs. And so this is basically property. Basically we've written our property-based testing framework right here. It's not a framework because it's a single function, but that's how simple it is. Right, so this is what the tests look like. We have a property function, which is like the commutative property where the parameter order doesn't matter. And the property function just like takes the two inputs, calls the function with the inputs reversed, and the answer should be the same. And then our actual tests look like this. We have a test for the particular thing, and we just check that that particular property function is always true for random inputs. So here's the second property. Now, we only need one of the two inputs, but here's the example. Here's written as a property. We add it once, we add it twice, and the answer should be the same. So it always returns a Boolean. These properties are always Boolean returning functions. And again, if we want to use it in a test, we take this Boolean returning function and we pass it into our property checking thing, which again, it checks that property for 100 random inputs. Okay, now if you're a mathematician, you'd recognize adding one twice is basically a very crude version of associativity. So the real addition property is associativity. And the third one, adding 0, we call this the identity property. If you add 0, it's the same as doing nothing. And we write a test using that. And there we go. So let's review what we've got. The parameter order doesn't matter. Doing add 1 twice is the same as doing it as adding 2, and adding 0, doing nothing. These properties apply to all the inputs, no matter what they are. No matter how random they are, these things are always true. So we have a very high confidence. Going back to my original statement, we haven't tested all 4 billion inputs, but by choosing random inputs and they always work out, we have a high confidence that the implementation is correct. So we've basically written 3 tests, and rather than 3 example tests, we actually have 3 property tests. Now, these things have words in mathematics. We call this commutativity, associativity, and identity. And this is not just a test. This is actually now a specification. Anything that implements these 3 properties is addition. Okay, that actually defines addition. So by defining it, you literally can't, if you pass these 3 tests of these 3 properties, that meets the specification of what addition is. So you literally cannot create an incorrect implementation. So that's the idea behind property-based testing. You can see it's pretty straightforward. It's something you could write yourself in a few minutes if you wanted to. But yeah, I just want to re-emphasize that by using this kind of property specification approach, we've actually understood the requirements in a much deeper way. If we just said that 2 + 2 is 4, that's just an example of what addition is. Because 2 × 2 is also 4. It doesn't really narrow it down. It doesn't really tell you what the true meaning of the thing is. If we use specifications like this, it really helps to drive a deeper understanding of what we really, really want the system to do. Right, so why bother with this example? This kind of malicious programmer is realistic, very unrealistic, very over the top. Nobody would ever do this, surely. So here's a way of thinking about it. We have evil people, we have stupid people, and we have lazy people. And it doesn't actually matter which kind of person you're dealing with, because whether they're evil, stupid, or lazy, they will still mess up your codes. Stupid people can cause bad bugs just as much as evil people. So, it doesn't really make any difference. And there's actually one person I've always had to deal with, one particular stupid person in my career that I've dealt with a lot, which is kind of frustrating. Here's the stupid person, it's me. And when I'm writing code for the first time in a new project, I often don't understand the requirements, and I often write code that I'm not happy with, and it often has bugs because I didn't understand something properly. And so I'm the real enterprise developer from hell myself, especially myself from 6 months ago, who was too lazy or too stupid to do something. And I'm sure that a lot of you have the same experience. You look at old code and you think, yeah, I could have done this completely in a different way, because now that I'm older and I understand the system better, I could probably write it in a much better way. So that just comes from, there's nothing wrong with that. Happens to all of us. It just comes with learning about the system better. Right. So it's not because I'm evil, but just because I'm unaware and I'm blind sometimes. So doing the thinking, and this is the lazy thing, we're too lazy to think. If I had spent more time thinking about the properties, that would probably help me get better tests. And also it helps me understand the requirements better. If I ask, well, what is a property that always has to be true? If I can't come up with a good answer, it means that I probably don't understand the system yet. All right, so that's the homemade way of doing property-based testing. But let's look at a library. You don't really want to write your own test this way. And the library is called QuickCheck, and it's a toolkit for doing property-based testing. It was originally developed for Haskell, but the ideas are now available. Pretty much every programming language has a property-based testing framework, or sometimes it's called QuickCheck framework. Very, very good. I highly recommend that you look into these. So this is how it works. You have this library has an API, and inside there's two things called a generator and a shrinker, which I will talk about. So you have your property, which remember is a function, and it's a function that returns Boolean. You pass it into this API, and the first thing is that the generator part generates random inputs to generate random inputs for your function. But then the second part, the shrinker, creates minimal failing inputs. The problem with having completely random inputs is they might be some incredibly random large number, and it doesn't really tell you what's gone wrong. It says, yeah, well, this thing failed if you pass in 475 billion or something. But yeah, that's not very helpful in understanding what's going on. So having a minimal failing input is really, really useful. So let's start off with showing you some code. So here is our correct implementation of add using the built-in library. So here's our property that should always be true no matter what the inputs are. And then in F#, which is what I'm using, you just say check this property using the built-in QuickCheck library. So that's how simple doing it is. It sounds like it's something kind of complicated, but it's actually really simple. It's just a few lines of code. And when we do this test, if everything runs well, we'll say a message like this: we passed 100 tests. So what it did is it generated 100 random inputs for this property, and every single one of them returned true. Right, so let's look at how the generator works, because it's kind of interesting. First of all, there's generators for all the primitive types. There's an int generator, there's a string generator, which is really useful because it generates random Unicode strings with non-printable characters and all sorts of weird things in it, which you might not normally think about if you're testing your strings. There's a Boolean generator, so it just generates random Booleans, true and false, whatever. So those are the kind of basic primitive generators. And then what you can do is you can generate compound types. So if you want to generate pairs of integers, you just say, I want you to generate pairs of integers, and it will do that. Each part of the pair is going to be a different integer. In functional programming, we have the optional type, and so you can generate optional types the same way. Sometimes it'll be something, and sometimes it'll be nothing. And if you have your own custom type, so I'm defining a custom type in F#, and there's 3 different choices. This is kind of like an enum, you can think of it. There's a red case, there's a green case, and a blue case. And in the green case, there's an integer associated with it, and in the blue case, there's a Boolean associated with it. So this custom type, the quick check library will normally be able to handle it nicely. It will just generate random instances of this thing too. So a random green, a random red, a random blue, another random green, and so on. So in functional languages, we have something called algebraic data types, or I like to call them composable data types, because in a composable type system, bigger types are built from smaller types, just like using Lego. And because they're built from smaller types, if you can generate random data for the smaller types, you can also generate random data for the bigger types, because they're just composed from the smaller types. So it really, really fits well with property-based testing, unlike the object-oriented style of defining classes, which doesn't really fit so well. Right. So here is our property. I'm going to use this property again. And we have these 2 parameters, x and y. And when you pass it into the checker, it says, it figures out these are integers. So it will generate, it automatically figure out I need to generate pairs of integers. So it generates pairs of integers, and then it passes them into the property, and it does it for 100 times, and then it sees if it's true for every time. So this is how the checker works at the crude level. Basically, again, it's something you could write quite easily. Right, now here's the nice part, which is this shrinker component for dealing with failure. I'm going to demonstrate that. I'm going to use a very crude example, which is we have a property called the number is smaller than 81. Now this property will obviously fail for numbers that are bigger than 81. So we know this property will fail, but let's see if the shrinker can help us figure out exactly what the boundaries are. If we did this property with our random one that we implemented by ourselves, it would just generate random integers, and it might fail with, like say, some very large random number, which really wouldn't be very helpful to help us narrow down what the problem is. So let's see what we can do here. So we know this is going to fail. So the quick check will generate a whole bunch of random integers, and it gets up to 100. Now, all the other ones pass, and when it gets to 100, it fails. Right. Now, rather than just saying it failed with 100, we're going to start again and see if we can narrow it down. Okay. So what can we do? Well, what we do is we generate numbers smaller than 100, which is why it's called shrinking. So we generate numbers up to 100 and see how it works. So when we generate numbers up to 100, it doesn't generate all of them. It takes kind of a kind of diminishing series that get diminishing as it gets closer to the answer. So in this case, it generates 0, 50, 75, 88, 94, 97, and 99. Now, in this case, when we run those numbers through the property, it fails at 88. Okay, well, that's good. We're just going to start again. So now we're going to start shrinking from 88. And this will generate all the numbers up to 88. 44, 66, 77, 83. And 83, it fails. So let's do it again. So here's our list for 83. And we have 42, 63, 73, 81. So it fails at 81. All right, and then we do it again. So we generate all numbers up to 81. Now, if we run this, these ones all pass. So we know that all the ones up to 81 pass, but 81 fails. So it has figured out that 81 is the smallest failing input, which is great. So when we run this thing, if we ran it interactively, it actually says the answer is it's falsifiable, meaning that there are some values where the property is false. It did 23 tests, it did 3 shrinks, and the smallest failing one is 81. So it literally tells us where the boundaries are in our errors, which is really, really, really nice. And it works for more compound types. Obviously, I used integers as a simple example, but it will work for more complicated types as well. It'll try and find a smallest thing that will fail the test. Right, so that's how property testing works. And people, when they see this, they say, this is great. But when they try and do something, they kind of get stuck. It's like, how do I even choose a property for my system? So, what properties should I use? I can't think of any when you actually try and do it. So I'm going to show you some properties that you can use to get some ideas from. So the first one, this is probably the most useful one in general, is that you take different paths, but you get to the same destination. So if you start off with ABC and you do something and you do something, you end up at 1, 2, 3. And if you go in a different direction, you also end up at 1, 2, 3. So for example, commutativity, which is if you do it in one order, you get an answer. If you do it in a different order, you get the same answer. Associativity is another example. Map, monad laws, functor laws, these are all the same kinds of things. I'm not going to get into that right now. But let me show you a concrete example. Let's say that you've got an implementation for sorting a list, and you want to check whether your implementation is correct. Now, as we said, you don't want to write a whole bunch of examples to see if your sorting implementation is correct. You want to have it want to do it for random data. So how can we do that? Well, if we take this approach, what we're going to do is we're going to manipulate the list and then sort it. That's going to be one way. And then in the other way, we're going to sort it first and then manipulate the list. And hopefully we end up at the same answer. So what we're going to do is we're going to manipulate the list by negating all the numbers in a list and then sorting it. And now, -3 should be the first answer. Now, if we do it the other way around, if we sort the list first and then we negate all the numbers and then we have to reverse the list as well, we should end up with the same sorted list, the same answer. And if this is always true, then we probably have a good implementation of sorting the list. Let's say you want to map something. So the map is a transform applied to an object or a type. And I'm going to use an example from Kent Beck's unit testing book a long time ago, where he used currency as an example. So I want to check that if I manipulate currencies, that my code is working. And again, I don't want to write some unit tests. I want to be sure that it's pretty much working for everything. So if I create a currency and then I transform it somehow, that should be the same as transforming the data before I create the currency. So let's say the transformation I'm going to do is just multiplying by 3. So if I create a currency with 2 in it, and then I map it to multiply it by 3, that should be a currency with 6 in it, hopefully. And then if I do the other way around, if I start off with 2 and I multiply by 3, and then I create that currency, I should end up at the same point. So if I don't end up at the same point, my map function is probably wrong. And so this is a nice, for things like mapping or in LINQ, this would be called select. It's a great way to test these kinds of functions because you don't really care what the inputs are. So another common pattern for properties is doing something and then going backwards, there and back again. Let's say you want to serialize something and then you deserialize it, you should end up at the same place. If you add something and then subtract something, you should end up at the same place. If you write something and then read it, you should have the same data. They're not literal inverses, but it's basically going in one direction and then coming back in the other direction. Setting a property and then getting the property, you would expect these to work. So very, very common ways of doing testing. A classic example is doing a list. If you reverse a list and you reverse it again, you should end up with the original answer. Now, obviously, you could also just do nothing to the list. So this is not the only property that you need, but it's a useful, very easy property to test. And this is a very important point. It's very rare that one individual property will do everything. You often need a combination of properties, not just one. Just like we had for addition, the individual properties, they eliminated some of them, but the combination of the 3 properties together was what really narrowed it down. So here's a really helpful property for this kind of thing, which is when you transform something, something about it is still the same. For example, the size of a collection. You know, if you sort a collection, the size is the same. If you map over a collection, the size is the same. If you reverse a collection, the size is the same. The contents of a collection, they don't change when you sort it. They don't change when you reverse it. You often have, you know, things like balance trees, or whatever. There's some property that even if you add things to the balance trees or remove things to balance trees, they're still balanced. That's part of the definition. Some, you know, invariant they have. So we had this list sorting example before, and I said that was a pretty good test, but of course we haven't taken into account the enterprise developer from hell, who will try and come up with an implementation that passes this test in an evil way. Right, so this is the you can beat this test if you're evil. So the evil sort, the implementation of evil sort is literally just returning an empty list. So if you negate it and then sort it, you get an empty list. If you sort it first, you get an empty list. So no matter what you do, you get an empty list. And so these paths are the same thing. So this is one property, but there's a workaround, you know, to make a bad implementation. So how can we improve this property so that the enterprise developer from hell cannot have an evil sort implementation? So this passes the test. Okay, so bad Garfield. Well, we can say some things never change. No matter what you do, when you sort a list, the output is going to be a permutation of the original list. It has to have the same content. And this will kill that evil sort straight away. So the sorting thing will check whether it's sorted, and then this extra property that the list has the same contents will also stop the evil implementation. So these two properties together will pretty much prove that a list is sorted. Okay, so that beats the enterprise developer from hell. And this is the kind of thing you have to do, is you have to have multiple properties. Here's another one. When you do something twice, you end up with the same answer. So if you make a distinct collection and then you make another distinct collection, it's the same as the first time. Idempotence, this is a good property. Sorting, if you sort it and then you sort it again, it's still sorted. If you do a filter and then you filter again, it's like doing it the first time. If you process an event and then you process that same event again, really nothing should happen. If you're doing any kind of distributed design, this is a really, really important property that is, you know, handling events twice it's the same as handling an event once. Smalling a solver problem, solving a smaller problem is a very common thing. If you can have a property which works for a small bit and you can extend it to the big bit, that's a nice way of doing it. And it often works when the solution is also done the same way. Like, for example, quick sorts of a list is you sort smaller lists and then you add them together to make a bigger list. So if you have those kinds of implementations, you can also have those kinds of properties. So any kind of divide and conquer algorithm will be amenable to this kind of property. Any kind of structural induction, like a recursive data structure, you can use this kind of thing for it. So very useful. Here's another one which you run into quite a lot, which is there are things which are quite hard to prove, but they're quite easy to verify. So if I have an algorithm that figures out how to get through a maze, you know, it's hard to know, it's hard to prove that algorithm works. However, if it does give me a path, it's really easy to check whether that path goes through the maze or not. So it's often easy to check things, even though it's hard to implement them. And the classic example of this is prime number factorization. You know, it's really easy. It's very hard to factorize numbers, but if you do have if someone gives you some factors, it's really easy to multiply them and prove that they add up to the big number. Many examples of this. I'm not even going to go into them, but this is just to show you this gives you some ideas of different kinds of things you can do. So here's an example. Let's say you have to tokenize a string with using commas or any kind of parsing or tokenization. it's kind of hard to prove that the tokenizer works, especially if it's a complicated parsing thing. Here's a simple one. Let's say you just need to split something at the commas, and you get, after you split it, you get 3 different substrings. Now, testing the implementation is quite hard, but testing the output is quite easy. You just take these 3 strings and you combine them, and you should get the same string as what the input was. And so there's an example where it's easy to verify that the output is correct, even though it's quite hard to implement it. And then a more complicated thing, if you have a parser that builds up sort of complicated parse tree, it can be quite complicated to check the parser. But if you take the parse tree and you regenerate the original source code, that's a good way of checking whether your parser is working or not. Let's look at the sorting thing again. People, unfortunately, with property-based testing, people use very simple examples, and I'm not going to be an exception. The reason is it's hard to explain the stuff on a slide. So people use list sorting and list reversing and things. Real-world property-based testing is much more complicated than that, and I will give you some resources for that at the end of the talk. You can check them out. Right, so let's say that we want to have something that's really easy to prove that a list is sorted. Well, it's kind of hard to prove that an entire list is sorted. However, it's really easy to check that the pairs, the adjacent pairs, are, the first one is less than the second one. So for each pair of numbers in the list, it's pretty easy to check that they're related that way. So if the individual pairs are related that way, then hopefully the list as a whole is sorted. But again, we need the property that the entire contents is the same, because again, we could have the evil sort where you just return an empty list, and that would pass too. So that's it's a quick way of verifying that something is sorted. Now the final one is something called the test oracle, and the test oracle is where you have a system under test, and you have some other system, the test oracle, that does have the right answer. And what you do is you run the system under tests, and then you run the test oracle, and you compare the answers. And if you think about it, that's really what example-based testing is too. Your brain knows what the right answer is, and you compare it with what your system says. But in real world, you often have much more complicated test oracles. For example, you have an optimized version of an algorithm, and you have the brute force version, and you know that the brute force version works, but it's really slow. So you can compare the brute force version with the optimized version, and if they give the same answer for every input, then you have confidence that your optimized one is actually correct. And another example is parallel versus single thread. So you have a single thread version that you know works, but you want to parallelize it. Are you sure it still works? Well, just check it using, compare them side by side and see if you still get the same answer. And this is really common when you're trying to get rid of a legacy system with a replacement system, and you basically use the legacy system as an oracle for the replacement system, and you keep comparing the outputs, and if the outputs are always the same, then you have a good confidence that your replacement system is actually working the same way. Right, so let me talk about model-based testing. All these things have been property-based testing, but sometimes, and in property-based testing, we're dealing with pure functions with, they're very deterministic, they're very explicit in terms of you have this input, you always get this output. So in the real world, sometimes you have things that aren't that deterministic, like a database. Anything to do with, the real world is sometimes more complicated. And so that we can use something called model-based testing, which is the test oracle approach for sort of real world things. So let me show you how this works. Let's say that you have a simple database and you want to test whether it works or not. Okay, now a real database is incredibly complex, but we're going to test our database with just 4 operations: open the database connection, close the database connection, increment a field in a record, and decrement a field in a record. And we're going to have 2 different clients because we want to test concurrency. And what we're going to do is generate a random list of those operations. And so here we go. client A is just randomly says, okay, you open and then you increment and you close and you increment and you open and you close, and for client B, open and then decrement and open again and increment and so on. So just a random list of these 4 operations. Now, how do we actually use this to check that our database actually works? Well, what we do is we take these operations and we run it on the real system. But at the same time, we take the same operations and we test it on a very, very simple model, like an in-memory accumulator in our case. So we're just adding and subtracting 1 in the memory, So, for example, in our model, we started with 0, and then A increments it by 1, and then B decrements it by 1. Now A tries to increment it, but A has closed their database connection, so nothing happens. And then, so this is our model takes into account whether the connection's open or closed. And then finally, B tries to open it, tries to increment it again, and everything works. So if we do in our model, after running this, we should expect that the answer is 1. And if we run it on our real system, we should also get the answer 1. And if we don't get the answer 1, then our real world database has a concurrency bug in it. So that's a quick way of testing real world systems. And there's a great example from John Hughes, who is one of the creators of QuickCheck. They had an Erlang library, and there was this really painful bug, and they spent months trying to find out what the bug is. And John Hughes basically wrote a test to see if they could reproduce it. And he did reproduce it, and the steps were super bizarre to reproduce. You had to open and then close and then open a file, and then you had to have 3 different operations running in parallel to cause the problem. I'll actually show you. This is actually a slide from his presentation. You open a file, close a file, open a file, and the 3 different clients, one client does a lookup, another client does an insert, and the third client also does an insert at the same time. And if this happens, the database file gets corrupted. Okay. Now, what's interesting is we had these bizarre steps. No human would ever think of writing a test for this. Very, very bizarre. Why would you open and close and reopen straight away? So this was the test case. The QuickCheck found this issue pretty fast, and the shrinker is really important part of this, because you could probably find a test case where you do 20 different things in random order. But that's not very helpful to understanding what the problem is. By using a shrinker, you can actually find the minimum test case. So in this case, if you did 2 different operations in parallel, 2 clients, that wouldn't reproduce it. You had to have 3 different people doing these things at the same time. And that would be the minimal thing that would fail. So there's great John Hughes talk about this from NDC Oslo 2013. There's the link if you want it. By the way, I will put these slides on Slack, so you can look at these slides later. Right, so let's just to finish up, let's look at the difference between example-based testing and property-based testing again. In property-based tests, they're much more general. We're testing hundreds of random inputs, right? Which means that one property-based test can actually replace many example-based tests. Also, they can reveal overlooked edge cases. Like when you're doing your example test, you tend not to think about strings with non-printable characters. You tend not to think about massively negative numbers or massively positive numbers and stuff. These things should be thought about, and nulls and so on. Property-based testing, they don't care. They can just randomly generate the stuff. They're not human, And the more of a kind of deeper thought here is that understanding requirements is tricky. And property-based tests force you to think, which is obviously a bad thing. But if you do want to think, property-based tests will definitely make you think about what's important when you're testing. Now, example-based tests are still helpful. It's not either or. It's and. So example-based tests are great because they are very easy to understand. They're less abstract. They're very explicit, and 2 + 2 = 4 is a very nice little test to show me what addition does in a very simple way. So it's a great way in terms of documentation. If you really want to have a thorough testing, they're not so good for that, but they both have their place. It's not either you have to this one or the other one. You can use both example-based tests and property-based tests. So to sum up, be lazy, don't write tests, generate them, and use property-based test thinking to gain deeper insight into the requirements. So there's a bunch of resources out there on the internet. If you search for property-based testing and your language, you will almost certainly find something. All the functional languages have them. Python has a really excellent one, and I don't know about PHP and so on, but I'm sure there is one. A lot of the posts you'll see on the internet are kind of theoretical, just like my one, with very simple examples. But there are some good real-world examples out there. All the John Hughes talks are great. That's the link to that one again. He's got a couple on property-based testing. There's a really nice series of blog posts, property-based testing in a screencast editor. Like this is a real-world thing with video. How would you test that your video editor is working correctly if you're writing it? And there's an ebook there as well too. And also worth checking out is metamorphic testing by Hillel Wayne. And metamorphic testing is related to property-based testing in the sense that you change things. You don't know what the right answer is, but again, 2 different routes should give you the same answer. And the example there is, let's say you're doing image recognition. You're trying to do facial recognition in an image. Well, you don't really know where the face is, but if you rotate the source image, the facial recognition part should also be rotated. And if you make the input image black and white, that shouldn't change. That should give you the same location for the face. And if you change the colors on the input, that shouldn't change the output and so on. So you can actually do a lot of testing to check that your algorithms are correct, even without knowing what the right answer is. It's really knowing that 2 different paths give you the same answer, just like I had before. So that's worth reading. So thank you very much. That's the end of the talk. If you want to have any, I'll be on Slack after this talk to answer any questions. I will also post these links on Slack so it's easier for people to read. I have the slides and the video will be up at my website, F#Fun&Profit /PBT. I'm not sure if we can do Q&A at this time. I'm not sure. Can you hear me, Martin? Nope. Okay. So anyway, I think that's it for me right now, and I will see you on Slack.
Okay, good morning. Do we have audio? We do? Okay, good. Good morning, everyone. As you can see behind me, it's dark here in Tennessee, just before 6 in the morning, but I'm still happy to talk to you. I'm the last thing between you and lunch, but still I'll try to make it interesting and make it worth your while. My name is Billy Hollis. For those of you who don't know me, I've been, as you can tell from my hair, doing software for a long, long time, always focusing on the user experience aspects of it, back when we called it ease of use and things like that. And I started really delving into UX design quite a bit about 12 years ago. And one of the tools that I used to understand it when I made the transition from primarily developer to primarily UX person is the science behind it. I'd always studied quite a lot of biology, but understand that's not the way most designers do it. They have more of an intuitive, emotional feel for the way they look at design. I know developers, you guys have to have reasons for stuff, sort of tangible reasons. So this session is to help you understand a little bit about some of the principles behind why designs are good or bad. And in many cases, I'll do that by showing how things work sort of in your own mind. Let's get over to my slides here. And that's more important now than it's really ever been in our industry, because I'll be honest, for most of my career, it was a nice to have if you made things easy to use, but people didn't really care that much, and they didn't value it, and there were almost no jobs that were focused on making things easier to use. Well, you look at where we are now, and you look at, for example, the Uber app. The entire value of this company Uber is in that application, and it has to be easy to use. That's why the company even exists. Whereas the one more on the right there, many of you probably have screens in your own application that are somewhat reminiscent of that. So understanding what your users see is the key to getting designs that are intuitive like Uber, and staying away from designs that they won't understand as well. I mean, A/B testing is very popular now, but how do you know whether A or B or maybe some C that you didn't think about is the right choice? If people like B, why did they like B? Could we have come up with something even better? So you get better designs faster if you have some understanding of design principles. Now, I recommend you go watch this video afterwards and watch it sort of in a relaxed state of mind so that you'll get the point of it. It shows you an example of a design principle. But instead of playing video over video, what I'm going to do instead is to do another test that's related to the same design principle. What I'll do is I'm going to show you 3 slides for a few seconds each. And each slide will have some drawings, clip art basically, of common tools that you would find around your house or workshop. And you have a task in watching these slides. Remember, each one's only going to be up a few seconds. You need to tell me at the end how many slides contain a hammer. Are you ready? Now, that's not a hard test. Your visual system naturally, primed by the goal, finds the hammers, and everybody will pretty much find 2, the first and last. The middle one did not have a hammer. And that's fine, and most people have any trouble with that. But now, if I start to ask you questions like, yeah, but how many pairs of pliers were there? How many pairs of scissors? How many wrenches? Now, you didn't really look at those because you weren't primed for that particular goal. And if we go back and we can go back and actually look and see that, for example, every screen has a pair of pliers on it. There's the first screen, and there's the second, and we see the pliers in the middle. And down in the bottom right corner, we see the pliers for that one. But your brain filtered that out the first time through because it didn't align with the goals. And that's the way your visual system works. It actually is very goal oriented, and you only see actually a fairly small portion of your visual field, your overall visual field, at any one time. And the design principle based on that is called inattentional blindness. I'm going to get to a few more details here in a moment. Some of the other visual principles that we'll look at, some of the other design principles based on the visual system, will include Gestalt principles, proximity, similarity, etc. We'll look again at some real-world examples of those. We'll look at using color and hue to signal information, and size. I've neglected to put that on the slide. We'll look at archetypes and familiarity, things that prime you to see things a certain way because of your experience. Getting back to inattentional blindness, I like to look at it first as a design principle because it is partially based on the anatomy of the eye. If you took biology, you may remember that there is a part of the visual system, the retina, called the fovea. And that part is actually pretty small. If you look at, that's a United States quarter there, and it's about the same size as a full moon overhead on a clear night. So that's the part of your visual system that has high resolution. The rest of your visual system really does not have high resolution. Your visual system works by moving that little piece around to whatever it thinks it's supposed to pay attention to right now. So you focus on what's at hand, and anything your brain doesn't consider relevant is pretty much just filtered out. That is a design principle because it's based in the way our visual systems work, and we can't reprogram people to change that. We have to take it into account in our designs, and it influences whether our designs are good ones or not. Remember the screen I showed that was on the right hand a few minutes ago. I want to take that away for a second and bring up a program that has that same screen with a little bit of a variation. So here we are. There's that same screen, but I've written this program to simulate the idea that you can only see a little bit of the visual field on high resolution, and the rest of it's just kind of filled in and you don't really see it. How many of you noticed, for example, the person, the demographic information, because that screen was up for several seconds. Did you notice that it was Sherlock Holmes? Probably a few of you did. Typically when I ask the audience, I find that they do. But very, very few people notice that the further you get to the right on this screen, the more it's just gibberish. It's meaningless. We start to get over here. What are those words? They don't mean anything. And it's very, very likely that you really didn't notice that when you were looking at the screen in the first place. What's a Fisher table? What's a dingle plop? What's a raster possum? See, your brain pretty much filtered that out and didn't really read it, even though it was in your visual field quite sharply when we were looking at it on the slide. Let's bring that slide back up. So that principle of inattentional blindness is based in the fovea, and this is kind of my example of the fact that users don't really see those complex screens that we put in front of them. It's more like this. So if that's the case, why do people bet for crowded screens? Because some users do. Well, they don't trust you. They assume that if you don't put the information somewhere where they can eventually find it, then it'll be hidden and they'll never find it at all. And that's because we as developers often don't understand their jobs well enough to really zero in on what information is important and what information is not. And since we don't know what information is important, we don't emphasize the important information, and we may hide information that is important. So how do we reorganize to get better screens? How do we get away from such crowded screens? Well, some of the more modern user experiences on phones can lead us in that direction. I've listed at least a half dozen patterns for how you can reorganize information in such a way that screens aren't so crowded. But the one that probably most people have experience with is something like the settings dialog on the iPhone. If you notice here, things are pretty spread out and everything is nicely categorized. So I can go to all the settings regarding Wi-Fi right away if I want to. But I also have the ability to search. If I'm interested in something regarding brightness, I've got the ability to go to that very quickly. So even though I have what's a screen that could potentially be crowded with a lot of things, and if we did it in a corporate world, we might just stick all those settings on there, then that's not an optimal experience for the user. Even if we're going to put it all on one screen, we still are going to serve them better by giving them a search to help zero in on the thing that they want, because, as we've seen, it's really a struggle for them to actually see the individual pieces of crowded and complex screens. Peripheral vision doesn't do much for us in software. Mostly what it does is draw our attention to things that the visual system detects, typically motion, and that will cause it to direct the attention over there. And the main implication in software for the peripheral vision is that you don't want to use animation gratuitously. Animation can be useful. It can be the thing that draws people's attention to some animation, some warning or some error. Jiggling an error message just a little bit is a good way to draw attention to it. But you really risk going over the line there if you're not careful. That kind of stuff gets old really fast. So that technique, by the way, to attract attention is sometimes called peripheral pop. It kind of pops into their attention because you wiggle it a little bit. Other than that, the peripheral vision helps in low light because it's sensitive to lower levels of light than the fovea is, but that doesn't really apply to software. Okay, let's look at some more principles that are, again, based in the cognitive system and the visual system. Priming is another. What you see, what all users see, is very heavily influenced by what they expect to see. Let me show you what I mean. This is a picture I took at another NDC conference last year, about this time of year, actually. And I was in St. Paul, Minnesota, in a parking garage, took a walk to go get some coffee, and I come in on the bottom floor of this parking garage. Now, if you're in a parking garage on the bottom floor and you go to the elevator, how many buttons do you expect to see for the elevator? Well, you expect one because it's the bottom floor. It can only go up. What shape do you expect to see? Well, elevator buttons are normally round. So I walk up to this elevator and see a single round button, and without thinking about it, because, my mind's off somewhere else. I'm thinking about something else. I just automatically press that button, and the security guy comes on the intercom and says, yes. Well, he sounds pretty bored because this apparently happens to him a dozen times a day. So because priming led me to see that single round button as an elevator button, which it doesn't really look that much like an elevator button. But let me tell you, I pressed it. So once I realized that I'd made that mistake, I went over and looked at it a little more carefully, and now I see that it doesn't really look that much like a button. And then I noticed next to it is the button that I actually wanted. In that nice burnished metal so that it kind of fades into the background. Notice that the button is the same color as the metal panel it's on, so it doesn't stand out in any way. So priming led me to the wrong decision. You want to be very careful in the software you create, not to show things that people are going to easily misinterpret because they're primed to see them one way and you present them another way. I've got a couple more software examples coming up in just a moment. And take into account if it looks like you are moving in that direction of priming people in the wrong way, this design could be fixed several different ways. It would help a lot, for example, if that button to call security were red, make it big and red, then people would automatically go, wait a minute, elevator buttons aren't normally red. Why is this red? And that would tip them off. But I think an even better design, which was suggested actually by an audience member when I did this session a few months back, is you could put a little plastic panel over the top of the button that just flipped up. And then the action of having to flip it up would tip off the user that this is not actually an elevator button. So putting things kind of in the way of the normal path when you're leading them down the wrong path can be a way to make them reevaluate. And that applies to software as well. Framing is a related example. You see what you see based on your previous experience. They've done experiments where they showed people through model kitchens. Now, the experiment didn't tell the people in it what the experiment was actually for, because it wasn't, they were told it was a marketing thing. Here, we're going to show you several kitchens, and this is a marketing study. What it really was a study of perception. At what they did was, in like 7 or 8 of these kitchens, they left out the stove on 2 of the kitchens, and then they get at the end and ask people about what they saw and what they thought of things, and they just casually kind of ask what they think about the stoves in these places where stoves don't exist, and people believe they saw stoves that didn't exist, because part of people's frame of what a kitchen looks like is it's got a stove in it. So they just naturally thought they saw it. So if you go in a kitchen that doesn't have a stove, you might actually still remember seeing one. Oops, sorry, went one too far. Okay, then there is the stepping through and what's called habituation, letting people kind of get in the groove on things. And this is a related thing to kind of seeing stuff that's not there. Let me show this with software. I've got a little thing here. So let's suppose you've got this wizard screen and you're just kind of moving along, and you do some things, you press the next button, and you do some things, you press the next button, and you do some things, you press the next button. Well, actually, on the last one, it's actually a back button instead of a next button. And if you weren't looking very carefully, you probably didn't notice that. So let's run it again so that you can kind of see that it just kind of leads you down the wrong path. Start that over again. So and there, we actually flipped those 2 particular buttons. Now, you're probably looking at this going, what software developer would be stupid enough to do this? Because this is such an obvious bad idea. Well, I give you American Airlines, because they basically violated the principle this way. I can explain why they did it, to give you a kind of cautionary tale for how you avoid certain things because of the way that the visual and cognitive systems work. This was the 4th screen in buying a ticket on American Airlines a couple, 3 years back. This screen was up for about 18 months. And I can tell you right now, they were losing money every day that it was up. Because what happened is you would go through the steps, you would select your dates and flights and all that sort of stuff. This is where you supply some information, and particularly payment information. Now, every previous screen has had a button in the lower right corner that was basically a continue button. Go on to the next step. Well, on this one, I'm getting all the stuff, got everything set, and I'm in a hurry. I mean, I've got lots of things to do. So I think I'm done with the screen, and I just immediately scroll to the bottom and press the button that's in the lower right corner, which has always been the continue button before. But now it's the start over button, because I haven't put in the credit card information yet. See, they took 2 principles that independently sound quite reasonable, combined them to get a bad user experience because of the way people's brains work. They said, well, you know, we're not going to show buttons you can't press right now, because people don't. Some people prefer to disable buttons that you can't use right now, but some designers like the idea of to have the screen very clean, they'll just take that button away. Okay, fine. And then the second principle was, well, we're going to right align all of our buttons at the bottom. Those 2 things sound perfectly reasonable in and of themselves, but then when you put them together, you get this. So if I haven't supplied the credit card information, I get the start over button. Once I do, now I get the button arrangement that I expected. And having thrown away all of my information on the flight, let me tell you, it was a close thing as to whether I was going to actually use this airline or not. So as I said, a lot of people would make that mistake and grow frustrated, and then just go to Delta or something, United, and use a different airline. Another general principle based on, again, the visual system and how it works, is that shape and color signal information quite a lot better than text does. If you think about this from an evolutionary perspective, it's kind of obvious why. Shape and color have been a part of our visual system since the earliest animals that developed eyes. But text is a fairly recent evolutionary development, and only really human beings have it. I mean, you could argue that maybe some of the higher primates have some ability to recognize text at a more primitive level, but text is processed in a different part of the brain, and that part of the brain isn't nearly as efficient as looking at shapes and colors. And because of that, if you make people read too much, you just kind of blank through them, because reading takes more cognitive effort than seeing shapes. And also understand, a lot of your readers and viewers and users don't read as well as you do, probably, because typically people from the tech industries tend to be fairly avid readers, and they read pretty quickly. They also don't get the jargon that we tend to put in interfaces. So this is a spoof, but this is the sort of thing that it's a simulation of what I would see developers putting up to try to express the technical problem that somebody's run into. The OAuth token is not valid. It may be stale or corrupted, etc. Do you want to override default security protocols, which is a meaningless phrase to people? In fact, I also spoofed up what I imagine a typical person actually sort of thinks when they see this, when they read it. It's more like this, because the jargon doesn't mean anything to them. And what they basically get out of it is, do you want to go ahead and do what you were trying to do, or do you just want to quit? That's really all they get. And so they will typically press yes and go ahead and do what they wanted to do, because they've got jobs to do. So understand, as a general principle, you throw a lot of text in front of people, users are going to skip right past that. That isn't going to do any good. It's not going to accomplish the purpose that you think it is. And some developers go, well, that's the user's responsibility. I put the message up. They should have paid attention to what I said. Well, you can think that if you want to, but the users don't work that way, and you're going to get bad results if you think that way. Here is a better example of how you do use shape and color and text to signal information. So, for example, you look at, this is an application for fuel management, kerosene and fuel oil. I'm sorry, kerosene and propane. And you can see that the tanks in the visualization are different. There is a tank that, and if you have any experience whatsoever, remember priming now. Remember that experience primes you to expect certain things. If you have any experience in this industry, the green tank is immediately going to jump out at you as a propane tank, whereas the red tank which has a different shape, will immediately come to mind as a fuel oil tank. And so you try to signal things with bigger numbers. You notice, for example, that 17 days since last delivery is easy to find if they're in that top bar. Their balance due and etc. Those kinds of things are easy to see, and bigger text. It surprises me how little the size of text is used to emphasize important information. We could do it back in the 90s. I mean, classic Visual Basic and tools like that, and early HTML, all of those allowed us to make different sizes of the text that we put up, and yet very, very few people doing screens for users actually did that. We also see some other things. For example, use of shape. If you look along that bottom area down there, that's the last 5 interactions with the customer, the user, the client. What kind of interactions can you have? Well, you can have deliveries, you can have bills, you can have service calls. If you look at that, what do you see there that you would think would be a service call? Well, the shape tips you off. The first one, with the wrench shape, immediately draws your eye to that if you're looking for service calls, because your brain sort of associates that wrench icon and learns to do it even better as you use the software. So using shape like that will help people scan and find something that they're interested in. And it doesn't, if you make it with the right amount of emphasis, which is kind of dim and not very prominent in the foreground, then the foreground text that's in front of it doesn't really, you don't have any trouble reading that at all. The user has no trouble. They filter that out when they're reading the text, but when they're looking at it from more of an overall point of view, then they can zero in on the shapes. Another interesting priming, by the way, about this, and this is something that you find out by talking to users and understanding, and then you try to make the interface kind of simulate what they expect and what's primed. And notice that that last tank out there is just about empty. Now, I wrote the control to display this stuff, and then I have a spectacular person on my team who made it look far better than I did, but I kind of did the underlying logic. And the fuel level that I put for an empty tank was nothing. You saw no fuel at all. Well, if you are in the propane industry, you know there's always some fuel down at the bottom, unless the tank has been sitting open for a long time. It's just that it gets to a point where the pressure isn't enough to put propane out, so it felt unnatural to them for a tank to be totally empty. So we made it so that even at 0%, there's a thin layer at the bottom. So that's the kind of thing you leverage people's experience to help them see what they expect to see. Context influences what people expect to see quite a lot. For example, if I told you this is a map, all right, we've got some roads and we got some buildings, some campus map or whatever. Well, that's fine, but then if I tell you, well, actually, there's a word in the buildings. Did you see that shift in the way the visual system worked? That it was because it expected to see words, it was able to zero in on the words. The letters were always there. I said words, I meant letters, sorry. The letters were always there. It's just that when we had it like this, we weren't looking for them. And so it was very easy for just to assume that those are blocky sort of buildings. But we shift our vision based on what we're looking for. This is an example of a very famous principle called figure ground. You may have seen this very famous diagram here, which when you look at it, different people see different things. Some people see two faces in outline, in silhouette, and some people see a vase in the middle. And which one you see depends upon what your visual system decides is the figure, and what it decides is the ground. If you see the white as the figure, you see a vase. If you see the black as the figure, then you see faces. The ground is the part that your eye decides isn't important and tends to filter out. Well, what does that have to do with software? Well, we can use that principle, that design principle based on the visual system, to direct people's attention. This is an app we did back in 2008 when modern apps were first beginning. This was one of our first really big XAML applications. And we came up with this way of keeping users' attention on things as we put overlay screens. This would be a typical editing screen for a company, but if we edited an address, this is for salespeople, not the most sophisticated users, so we really want to direct and keep their attention going. So we decided, well, if they are going to an address to edit it, we'll put up an overlay screen, but we'll also gray out and shrink the screen that was in place. What does that do? Well, when it's like this, the figure is the editing screen, and the ground is kind of the stuff that surrounds it, which is why it's kind of muted. But then if we do this, we have shifted what the visual system considers the figure into the smaller screen. And the visual effect of graying out then tips off the visual system that that's the ground and they're not supposed to be paying as much attention to that. And we see this on websites now too. By the way, we animated the change between the two, the graying and the shrinking. But we've seen websites do this now. Because Twitter did this for a while. They sort of changed to a different interaction pattern, and I kind of like this better, because when you've got sort of the darker background and you've got the thing in front of it, it's really easy to zero in on the foreground, and you still have context. The stuff that the figure is sitting on top of helps you remember where you are as a user. So that's using figure ground to help direct users' attention. And these principles, you think, oh gosh, Billy, I've thought about these things for years, and when I explain them, most people get them pretty good. But it still surprises me, and has many times surprised me in the past, how quickly people can misinterpret these principles and use them wrong. for example, some of you may remember the Visual Studio 2012 toolbar, which had very washed out colors. And then, of course, they fixed it now. The bottom has the modern toolbar. Why did they make the toolbar so washed out and without color? Well, someone there said, figure ground. I just saw this principle. It's great, man. We're going to use that in our designs. And the figure, obviously, is the code, because that's what developers think of as the most important thing in the interface. But as we saw in the examples we just looked at, what the figure is can change depending on what it is the user is trying to do. And the person who designed the Visual Studio 2012 toolbar did not understand that. If they made it so that it kind of lit up and got colorful if you got a mouse over it, that would have been respecting the principle and it might have worked better. As it was, I was showing something in Visual Studio 2012 about 6 months after it was released. And I did like an uncomment or something up there in that toolbar. And a guy in the audience shouted out, I've been looking for that button for 6 months. That tells you just how bad a job somebody did by misunderstanding a design principle. And think about how many millions of people use Visual Studio. That was a non-trivial mistake, I guess is the way to put it. Past experience can prime you. We talked a little bit about the elevator button stuff earlier. And that's what makes people eventually learn interfaces that are almost incomprehensible when they first encounter them. The past experience eventually primes them to look for the right thing. It's just that we'd rather eliminate that struggle, that hill, if we can, if we can make it so that they're able to do it instantly. But I often say to people who are striving to find a good design that the reaction you're looking for from users is not, oh, that's a cool design. What you're looking for is that they see it and just immediately understand it. That it's just, they go, of course, how else would you do it? When users do that, you can be assured that you've got a good design because their past experience led them to see it well. Incomprehensible user interfaces don't do that. So to kind of understand some of that priming, this is one of my famous, one of my most famous pictures. This is an elevator panel that I took a picture of back in 2010. And the question is, why did I take this picture? You might look at it for a moment and see if you can figure out something about it that you go, I didn't really expect that when I got on the elevator. You might point it out to somebody you got on the elevator with them. So think about that for a few moments and see if there's something that you noticed there. And then I'll tell you what I noticed. All right. Now, that is what I noticed. Now, I find that the most common thing people see, somebody in the chat said there's no floor 13. There's somebody else, no floor 13. That is what developers normally notice. You've got that analytical brain going there, because you sit in your cubicle all the training that analytical brain. So you step in that elevator and go, there is a missing number in the sequence between 12 and 14. That's kind of your immediate analytical developer thing, but it's not what I noticed. And that kind of shows you a little bit about the difference between sort of how people look at things when they get primed by design principles. They start looking at the rules differently and they're a little bit more mindful about it. What I noticed was the paint worn off. Think about what that means. The paint worn off, that G, means that many, many times a day, somebody is getting on that elevator and wanting to press a floor, but what they press instead is the metal placard that's beside the floor button. Why do they do that? Well, we've kind of already covered all the reasons, haven't we? They get on an elevator expecting a round button. They see something that's round, they press it. They're not looking at the overall picture. Their eyes don't work that way. You dart around to little places that you think are important and don't see a bigger picture. Now, if you step back and scan through an entire row, you can figure out pretty easily that, okay, that's the button and that's the placard. But, people are on there, they're struggling with their luggage. They got their 3-year-old holding, dragging them along. People's attention is easily split between various things because we live in a complex world, and part of your responsibility is to take that into account. Don't make things hard to understand when people are distracted. By the way, since I saw that elevator, I've seen lots of others. This is one in Las Vegas at a very upscale hotel called the Signature at MGM Grand. And the paint is not quite as far along being worn off, but we can see the signs, can't we? We know that people are making the same mistake here. In fact, I got on this elevator. I was on floor 25, and there was a guy standing beside the pen. And he clicks the button, presses the button for 24. And immediately he's apologizing to me. And I go, no. Let me explain to you about the user experience design of elevator panels. So we had 24 floors to go through, so might as well have a little mini lecture in there. So instead of making it something that leading people in the wrong direction, you want to lead the people in the right direction with things like the fuel tanks I talked about before. And the empty, there you can see a better example. I think this is where I actually intended to talk about the empty fuel tank, but I got so excited I talked about it on the other slide. But this is the good a complete example of the 0% full tank. Still has a little bit at the bottom because that fits in with their experience, and it's primed to their experience. Let's see, what else did I want to look on that? I think that's probably all of that. Oh, here's another one. Yeah, let's go on to another principle. I get off an elevator in Texas, Amarillo, Texas, and I see this sign. It's about 11 o'clock at night. I'm tired. Talked about being distracted. I was tired. And I'm in room 207. So I see this sign and begin walking to the left. And I get 2 doors down and realize I'm going the wrong way. And then I go back and look at the entire sign. Remember, our visual systems look at just the minimum amount that we think we need to figure out what it is we need to do. We don't, by default, look at the whole thing. But I go back and I look at the whole thing and realize, no, I'm going the wrong direction because this is a poorly designed sign. The problem is that the closest arrow to the range that includes 207 is the one below it, not above it. And so my brain automatically just filtered all the rest out. It filtered out that top arrow. It filtered out those numbers. I'm not interested in 224 and 226. I'm interested in 201, 223, and which direction to go. So that's what I looked at, made the mistake, came back and figured it out. See, in a lot of cases, bad design doesn't prevent people from doing things. It just leads them to make mistakes that they have to go back and correct later. And you'd like to avoid that. The design principle involved here is called Gestalt proximity, that the eye tends to automatically group things that are close together. If these arrows were just, 8 or 10 centimeters further down, or even less than that, 5 or 6 centimeters, they would line up much better with the numbers that they represent. And the eye would automatically do that grouping, and we wouldn't have any problems. Now, how does this show in software? Well, this is a page off of Amazon from about 3 or 4 years back, where I saw this thing, and of course I travel, so having some storage backup is nice. At the time, $30 was a great deal for 128 gigs. So I see that thing, I see the description, and I go to the checkbox right down below where it says in stock, and check it, and go, okay, put this stuff in my cart. Go to my cart, it's not there. Why not? Well, some of you probably primed by the previous example have probably figured out why. Let's see if I've got kind of, if we can get the pen here. Let's get the PowerPoint pen, because this is not the checkbox for that item. This is the checkbox for that item, and that I hope you can see that that's exactly the same principle. That since with the white space that's involved in the photograph, the one at the top is further away and therefore not naturally grouped. So that was a mistake. Gestalt principles are again based, like in attentional blindness, in the way that the visual system works, because it's optimized to see structure and relationships. And so Gestalt proximity is one such principle. Similarity, common fate, we've already seen figure ground, continuity and closure. That's others, and that's not even a complete list. Let's kind of flip through some of them really quickly. But first, I want you to understand that this is happening in the visual system in the brain. There are stages of visual processing. That first, the retina kind of does some things to optimize the signal it's receiving, accentuates edges, for example. And then there's what's called pre-attentive processing, where at a more global level, things are associated into shapes and groups. That happens in a small fraction of a second. And that is where the Gestalt principles tend to be implemented in the visual system. Stage 3 is where you apply more experience. Because if you've never seen something before, then it's hard to interpret what it is. But if you've seen something, then you can apply that experience and recognize it. So Gestalt comes from stage 2. The visual system kind of gets the edges and shapes in certain ways and then puts them into groups and relationships, and it's unconscious. It happens before conscious interpretation. Now, the conscious interpretations in stage 3 can override the interpretations in stage 2. But as I mentioned earlier, you'd like not for that to be necessary because that requires additional cognitive effort that you would like to avoid. So we've seen proximity. Here's an example of when people are violated. Not only will it leads to various kinds of errors. One of the errors it leads to is if you get things too close together that are not related, it's really easy to make mistakes. For example, in this particular piece of software I was using, that button right there controls what most of us would think of as code behind. And the little thing right there, which is just awful iconography, wipes out all the code behind in that event. With no, at the time that I took the shot, it did it without any warning or confirmation. Well, how easy is it to hit that little thing when it's very close to a button, the edit button, that I use all the time? Well, that's very easy. So that's the example of violating proximity. Go back to the elevator example. Is another good thing there. Part of the reason why it's kind of hard to tell what's going on with this elevator panel is we've seen that issue, but why do we have trouble with kind of what button goes with what placard? Well, suppose that I screen it down to just this. I mean, suppose, for example, that you're blind and you get on there and you feel for the placards and you find the one that's 4. There are little dots there. You may not be able to see clearly that there are Braille dots on there, but there are. Okay, fine. Which button does that placard go with? It's equal distance between the two. See, the proximity principle would suggest just put the placard a little closer to the one that it's actually associated with. Now, developers are sometimes tuned into the idea of symmetry and consistency, and so are mechanical engineers for that matter. That's the reason they made this panel this way. It looked very symmetrical and everything was lined up in all these nice rows. Let's go back and kind of see. But that's not the primary. Just making things attractive aesthetically is not the right priority if you lead people astray, if you make the interface hard to understand. And developers are sometimes prone to that. They make all buttons the same size, for example. Well, no. If a button is used all the time, it should be big. So the proximity principle works inside your mind. I'm going to show you some slides with 4 pointed stars. And just think in your mind whether you see rows or columns of stars. And by the way, a lot of the examples in this session are taken from a book called Designing with the Mind in Mind by Dr. Jeff Johnson. Highly recommended book. Okay, rows or columns? Probably rows. Most people would see it that way. And in this one, most people will see columns. But did you notice that's exactly the same size array of stars? It's 5 across and 4 down. The only thing that changes is the spacing and the grouping. And your eye automatically determines groups based on that spacing. Rows or columns? You probably saw rows here. Most people do. A few people don't, but it kind of depends upon your sensitivity to color. But color can override positioning to help the brain group things. So in this case, the yellow stars are automatically grouped, even though you saw columns when you saw the same spatial arrangement earlier. So proximity can be overridden by similarity of color and shape and size. So we see the rows there. How about rows or columns here? Most people see rows here. The shape helps the eye automatically realize that all the things in that second row must be related in some fashion because they're all the same shape. And we've seen these principles in charting software. Proximity would tell you about a particular period, while looking at the color over time, the similarity of color over time would help you associate elements from a given category. Also, you know, I put this up, that triangle just actually jumps out at you in your visual system. If you violate some of these principles, it makes things stand out very easily and quickly. And it's not just shape that does that. If I tell you to find the green star here, you don't have to really work at that. There's no real conscious effort involved. The visual system unconsciously does that for you because that's the way our visual system is evolved to work. Let's do this in the form of software here. Discard. Because I've got a program for this. Let's see, where is it? Right here. So I've got some letters up here. If I told you to find the Z, well, you know, you'll eventually find it. You just kind of move everything around. But if I bold it, now you can find it almost instantly. And that's not a huge change. And yet the eye is able to pick that out pretty good. Again, notice that text and letters just kind of all blur together because that part of the brain isn't as advanced. But the differences in hue and things like that are much easier for the visual system to see. If I tell you to find a B, well, all I got to do is shift it over a little bit. And the visual system will pick up that discontinuity and see it very quickly. And those kinds of things can be used in software to help people see things that they might not otherwise notice. For example, if I've got a list of things and I really want them to notice something in the list, if I shift something over a little bit, then their eye is going to be drawn to that immediately. When you violate these principles, you start to confuse people. I remember the emotional experience of seeing this in the first place. Because you see that thing, this is on Android, this was the Southwest app, and it says GPay Save to Phone. That's confusing on a couple of levels. First of all, is this one button or two? Does the bar in the middle mean that I can click different sides or not? It turns out that no. The answer is no, but it isn't obvious visually. It's confusing for no reason. And pay, I've already paid for my ticket. Why do I do that? Well, what they mean is they want you to use the wallet on the phone to store the boarding pass, but they don't make that obvious. So that's an example of where the developer is going, yeah, you're using the wallet, man, that's GPay. But my 84-year-old mom's not going to get that, okay? I mean, I figured it out after a while, but she probably isn't. She's probably going to go, what's this about paying for my ticket? Gestalt continuity has to do with things, with kind of leading the eye. The eye tends to follow natural flows. And until it sees something that is discontinuous, and that draws attention to it. So it begins to track something, and it will continue kind of in that direction, that vein, until it sees something else. So you break the pattern, as I mentioned before, to cause something to be noticed. And this particular call, this is in a daily workflow. It's a prototype that we did, a daily workflow for a truck driver delivering propane. And notice that the offset, it takes a moment or two to maybe figure it out, but once you figure it out, this is what's called a sticky design. You'll always understand from then on, you won't forget, and that is that overlapped. If a particular task or commitment overlapped with another one, so that you have conflict, then putting one off to the side like that draws the eye draws the attention to that, so that you immediately see it. Let's bring a few of these principles together, do a real quick example. I want you to count the number of American football items in this set of cards, this card view of a lot of sports equipment. And there will be what you would call footballs, we would call soccer balls in there. There's baseballs, basketballs, etc. So count the number of American footballs. Again, I'm not going to leave it up very long. You see 3 footballs? Most people will see 3 because, of course, as we saw from the earlier thing, you probably didn't see baseballs or basketballs because you weren't looking for them. And that's because of inattentional blindness. But here's some ways to reorganize that and make it better. So, for example, there is the principle of mapping, that because of the experience nature of how we see the world, we have this mental image of how big a baseball is compared to a football or a soccer ball. And if we make the graphics proportional to that in some fashion, we give more clues to the visual system to immediately zero in. So finding the baseballs and tennis balls with their size makes that easier than some of the others. But we can do a whole lot more design principles. We've already seen proximity and similarity by color. Let's put all that together and maybe get something like this, so that all the baseballs together, now we see instantly that there are 3 American footballs. And by the way, I fudged this up as an example. I didn't spend a lot of time figuring out nice colors. I just kind of went with some of the named colors to keep it simple. But which one of these would you rather look at if you're a user trying to track down a sports item? And the work involved to do what's in the lower right corner there isn't very great. I mean, it's doing some sorting and doing a little bit of binding so that the background color is selected based on the equipment category. That's really easy to do in modern desktop software. And if you use something like Angular, you can do it in web software too. So we talked about information importance, that bigger was more important, that color made things stand out. Red family colors show that something is very extra important, danger or exceptional conditions. And if we go back to this, we see that being used. The red for fuel tank is there because they put dye in kerosene, and that's the color dye they put in it. But you notice the COD up there is red. From American business, that means collect on delivery, meaning these people don't pay their bills. You better get your money when you give them the product. So those sort of things, and the little smiley face over on the right, tend to and Mikhail mentioned, by the way, that there's cultural significance there, and that's true. In China, for example, red can be good. And so you have to take into account the cultural differences in your audience. But as far as I know, China is the only place that some of the associated cultures here are the only ones where red is considered kind of a good thing. For most people you're going to deal with in Europe, US, it's going to be green and blue are going to be better. Notice the smiley face over there. Your brain is optimized to see faces. It immediately knows that that's a satisfied customer. So those kinds of shapes and colors and size really do help the user zero in on things. Here's kind of another example from the same application. And notice that up there in the top that we're dropping down the things that aren't so important and raising the things up a little bit that are more important to kind of draw the eye to them. Notice that the overall background theme is fairly neutral. That allows the color things, the reds and the greens, to come out and be obvious. Also notice that the reds aren't that bright red. Very bright colors tend to be fatiguing. You don't really see those in nature much. So you don't have to make the reds very bright. I've got another slide for that later if we have time to get to it. What have I got? A little over 10 minutes left. Users are also primed by goals. We've seen that with the tools and such. So users should understand what their goal is, and you should understand what their goal is. When you go to design a screen, you should know what are the actions that they come to that screen to do. What are the pieces of information that they're going to look for to influence their decisions? If you don't know those things when you go to design a page or a view, then that means you haven't really studied the problem you're trying to solve enough. You should be going back and interacting with the users in various ways to understand what those things are, so that you make the important information easy to find and you make the important actions easy to get to. Now, if you subvert these principles, you can end up leading users in the wrong direction to get them to do what you want them to do instead of what they probably would do if they were fully informed, so to speak. And I consider this highly unethical, so don't misuse the principles. This is an example. They changed it a bit, but I'll this is a little over a year ago. Hilton wanted me to sign up for their frequent stay program. And so on the Android phone I had at the time, this came up when I got ready to install using the store in a web in the browser because the store in the browser will then go shoot it out to the phone. And I find it a lot easier to find apps and read reviews and things like that in the browser. So I do that, and it says, okay, this app has access to contacts. Why? Why does my hotel app need to access my contacts list? So to me, that was probably left in by accident. Some configuration was there by default, and the developer just never bothered to remove it. So that really bothered me. And what bothers me from the user experience perspective even more is notice how gray that is. It's a gray font on a gray background, meaning they really don't want you to look at it. What they want you to do is get that big green save the color, that big green install button. They want you to go ahead and install the app and not think very much about it. And I consider that unethical, that they're trying to get you to override your normal caution or cynicism just to go ahead and install the app. And even though that, for me, that's a security breach right there waiting to happen. And they changed it now so that they don't even pop that up. You actually have to go to a different place in order to make the security stuff pop up, which means they've hidden it even more effectively. I consider that just unethical. Citibank really wants me to go paperless. So they put this up, and I go, okay, accept paperless, manage settings. What does that mean? Does that mean I'm going to be led to be paperless whether I want to or not? I just want to go to my accounts. Eventually, I figured out if I press the Citi icon in the upper left, that happens. But they did not make that obvious. They want me to lead them in the direction they prefer rather than what I prefer. Other principles that influence what users expect. We've talked a little bit about archetypes and familiarity and habituation. Let's kind of flip through some of the additional examples for some of those. This is a page to hook up to the internet at a hotel, a Marriott hotel, and I see this. This is the screen as I saw it, and you see where it says high-speed internet in green. Well, that's what I want. It says it's free. I want to surf the web. I press that. Well, the problem is that's not a button. If I go ahead and make the screen bigger, I discover that the button is actually at the bottom, although how much does that header look like a button? And I've seen this several times where web designers have done this more often than I would like. They make their headers look like buttons, and I think they do it kind of for the consistency. But don't do that. Don't make things look like buttons that aren't buttons. Okay, yeah, no, we've already been through that. Now let's spend the balance of our time talking a little bit about color and how users see color. Because they don't see color the way you think they do. You see different colored balls here, but these balls are actually all the same color. If I start masking stuff out, see, that's two different balls, and actually underneath, when I get rid of all the distraction, they are the same color. That happens a lot because we don't see color in an absolute sense. We see color relative to the colors around it. So, for example, let's bring this up here, and I've made it so that that bar in the middle is monochrome. The gradient around it fools your eye so that you can see that I've got this little block. I swear to you that I am not changing the color of that block, even though your eyes think that it's a different color. So be aware that as you choose colors for things that are information that's going to stand out and things like that, that you choose those colors in relation to the overall color scheme. And by the way, that's the sort of thing that I know developers probably don't feel as comfortable doing. So that's an area where you can get help from visual designers. By the way, I've got that same thing with blue. Okay, it doesn't matter. It's a general attribute of the eye. In fact, this kind of, the research that was done on this yielded, some of you may have seen this as a famous optical illusion. And I'm going to tell you this, and your brain is going to just absolutely refuse to believe it. Square A and square B are the same color. The shadow fools your visual system into thinking they're different. And I can prove it by taking this thing and dragging. So you see that's kind of dark, but it's lighter than this, and then we get here, it's the same color as this. And now I kind of go up through here, and it's lighter, but it gets here. That's an amazing optical illusion there. But that helps you understand that the way the eye works, particularly with color, has a lot more to do with how the colors work together than it does with, you don't see color in an absolute sense. That's just not the way the visual system works. Okay, am I up against my time? I've got a few more slides, but is this? I can just go a little bit. Okay, I'll just hit a few more things then. Paleness makes it hard to tell, were those colors the same or not? You couldn't really tell, could you? But if I put them together, you can tell the difference. So paleness makes it hard to tell colors apart. Size makes it hard. The bigger this gets, the easier it is to see that the colors are different. And so legends on charts should be big. And tab header colors shouldn't be too subtle because the tabs are thin. So and I see this done wrong in various browsers. Visited links should be easily a different color from unvisited links. There's the legends. You see, make the legends nice and big. This is Opera, but I think they don't do as good a job as they should for the tabs. They don't really make the colors of the color of the active tab that different from the color of the other tabs, as opposed to Edge, which is more like this. Does a little bit better job there. I've talked about most of these things about effective use of color, keeping the theme subtle, not making it too bright, not too bright even for signaling. You saw some of the reds I talked about. And make your gradients very subtle for a natural feel. And there's somebody mentioned that in the comments earlier, that China good is signal with red, so you want to make sure you get your culture figured out too. Does use visual design specialists. Kind of the last thing I'll talk about in regard to color and how it integrates in some other things is smoothness actually affects mental perception quite a lot. And you think about that from an evolutionary perspective, your brain doesn't want to interact with sharp objects. Sharp objects are dangerous, thorns or sharp rocks or whatever. So that's programmed into us to do that. And I can show you, in fact, that that is a more powerful effect than words. Here, let me show you. You see that? That's kind of, you might send that to your significant other and notice the nice curvy font, and it feels all safe, and the curvy heart. Now let's take exactly the same words and change the font and change the shape and get this. Okay? That's the emotional meaning completely flipped 180 degrees just from changing those things. So be aware of the impact of color and of sharpness on your users, because the visual system automatically makes certain interpretations based on those things. Okay, I'm about 2 or 3 minutes over, but I'll take let me check the chat window if I can find it. And it's probably over here, isn't it? There's a chat window. I'm not. I didn't bring the chat window up, so I'm not sure where it is. Let's see, here we go. Is that the chat? Show grid. Oh, I see it's coming up there. What would you recommend as good starting material on the subject? There are some books that I would recommend. Let's see if I can bring up the URL for this. I should put this in the slides. Let's look at here, because I've got a bit.ly link for design books. So let's see if I can find that. Search. I think it's design books. Yeah, there it is. No, RecDes books. Okay, here we are. See that bit.ly link right there? bit.ly, and you got to get the capitalization right. I'll go ahead and bring that up so that you can see it. It's on my website. Oh no, you don't. I'm on the wrong monitor. Sorry, let me bring it over. Put it over here. BillyHollis.com/designbooks. And there are links to Amazon. Of course, it's American Amazon. You might have to I have to take that into account. But the book that's blue and white in the corner is an excellent starting point to understand design principles in general, including visual ones. The one that's got more of the examples from this session is this one down here, Designing with the Mind in Mind by Dr. Jeff Johnson. All of these are, I think, good design books, but those two are probably the best place to start. If you really like the elevator example and observing things in the real world, you might take a look at The Design of Everyday Things by Donald Norman, which was the first design book I ever read and really sensitized me to notice design in the real world. Okay, any more? The best for starting, well, I actually was the two best for starting: Universal Principles of Design, right here, the blue and white one, by several authors, and then Designing with the Mind in Mind. Right. Let's see. Oh, I don't have a pen for that. By Jeff Johnson, who is a neurobiologist. Those, if you like what I've talked about today, those are the two best books to start with. All right. Well, I always have fun talking about this stuff, even if I don't get as much feedback about how you liked it, but I hope you found it interesting, kind of a discovery channel for developers thing. And you're welcome to contact me with questions if you like. And I'll get on there's some stuff on the website, I think. You can contact me on Twitter at Billy Hollis, for example. You can discuss things there if you like. That way everybody can see it. Thanks very much, folks. I appreciate the feedback. People apparently did get something out of it. So I'm sorry that I couldn't be there with you in Portugal. I've never been and I wanted to be, but I hope this was, given the circumstances, an acceptable substitute.
Hi guys, my name's Ian Cooper, and hopefully you've come to hear me talk about service consumer patterns. So just a brief idea, what are service consumer patterns? So if you've built your microservices architecture, one of the things you're going to have to come to terms with is how your clients or how external partners are actually going to communicate with those microservices. And this talk is about the challenges that you face moving from, say, a world you're used to in monoliths to the world of microservices when you want to actually go ahead and do that. So today we're going to start talking about a little bit of a very short dip in just to refresh our memory of how we did this in the world of monoliths. And we'll look at two separate ideas, how we issued commands to our system in a monolith and how we queried our system in a monolith. Nothing earth-shaking here, we all understand that, just for context. And then we'll look at why the changes we make with microservices. We'll have a tiny bit about what a microservice is, why that we then get a challenge with microservices in using these same strategies. And then we'll tackle the problems in two parts. We'll look at queries first of all, how we compose queries to our monoliths, and we'll look at commands, how we actually issue requests to our microservices to do things. There's a lot to get through, so we'll have to move quite fast, and we'll have a little tiny summary at the end. Most of the slides are unimportant, just as I'm old. The point I really try and draw attention to is the one at the bottom. Everybody really can get into speaking, and actually, you know, nowadays with the pandemic, there's probably lots of opportunities to do little short talks at user groups around the world. So please do, it helps you get your head around topics if you have to teach them. And once you get over that initial hurdle of fear, it's really a great experience. I work on an open source project called Brighter. We deal with messaging in the .NET and Python worlds and kind of CQRS approaches. We're always looking for new contributors. You can find us essentially by just searching for Brighter command, and you'll find us really easily, or just hit me up afterwards in the Slack channel. This talk is one of kind of a pair. So last year at NDC, I talked quite a bit about event-driven collaboration. There's a tiny bit of crossover in concepts, but I won't dig into too much detail on some of those ideas in this presentation. And if you're interested in them, I'll just basically signpost that you can go and see my last NDC talk for more of a deep dive on some of those ideas. All right. So the first thing we want to start talking about is, what did the old world look like? Or for some of you, it still is the current world, right? So what is a monolith from my perspective? From my perspective, a monolith is really something where when we talk about deployment, we talk about deploying everything within the system boundary. Usually the constraint that makes that thing the monolith has to do is the fact that we have one shared database. And because a change to the schema of that database can ripple out to affect any number of actual components which talk to the database, then we end up with basically this idea of a monolith. Now, it may be that we are able to say, well, actually, I don't have to release every single thing in a monolith. I only have to release the things that are impacted by the schema change. But what happens is, in my experience, we end up with release meetings. We all sit around discussing that we found everyone's impacted by this change. We deploy to staging, something breaks in staging, and then we have to go back and figure out who that belongs to. Or worse, it breaks in production. And what that means is that the cadence of our release slows. And I quite often see this happening in most places I've worked in a kind of 2-week release cycle to get things out the door, which means that effectively, by comparison to your competitors, who could be releasing multiple times a day, this can be a problem. It's also much harder for multiple teams because all these teams continually have to coordinate their releases. One of the things we're trying to show here is that you might actually have components running in different containers. You might have 4 or 5 APIs that are all hosted on separate parts of your, say, IIS, or in separate Kestrel, or separate, basically, Django websites, whatever your flavor is. But because they're all sharing a database, they all have this constraint that they have to be released under a single boundary. But let's imagine a world that our monolith essentially has some components. It's probably all released as kind of one big website. and we built something that dealt with hotel software. Now, I apologize to everybody who may actually have dealt with hotel software at some point in their life, because I know nothing about hotel software. I just use it as an example because I know nothing about hotel software. I can move away from the details, and most of us have some experience of checking into a hotel, so we kind of understand what I'm talking about. So in the old world, I might have a kind of traditional layered architecture. I've got my API at the top. I've got my domain model, which is nicely modularized. Model is not a pejorative term, just a description of certain characteristics it has. With my big database at the bottom, and potentially I've got some ORM feeding data. And let's imagine the situation where I wanted to make a hotel booking as an existing customer that held an account with your business. Oops. So, getting the work done for a command. I decide basically to post my new booking. It comes in via the API from whatever client I'm using, be it a Spire application or something like that. And then effectively what would tend to happen is I would create a new booking using the direct bookings module. I've got some types in there I can create stuff with. And then probably I would save that early form of the new booking saying I had a tentative new booking to the database via my ORM. Then I'd know in terms of my business logic that I now needed your account information, because that's where I held the credit card details, and I was going to submit those to my payment system. So I'd then read from the database and get your account details back via the ORM, and having got your account details and getting the credit card information, I thought I could then submit that to the credit card payment system. Credit card payment system would probably call some kind of external payment provider like PayPal, etc. And once we got a message back saying that your credit card had sufficient funds and you could book the hotel room, I probably then talk to the housekeeping system and say, I'd like to reserve a room for this customer on this date. Housekeeping would then write to the database and say, let's store that particular room reservation. And then we might talk to a channel manager. So a channel manager talks to Booking.com and Expedia and says, we have a number of rooms available in this date with this range of prices. We may update via channel manager, hey, this rooms are really in demand right now, so let's basically up the prices. And again, that may talk to some external basically site to get the actual basically channels. And of course, you probably get the list of channels from the database. And as you can see, it's a fairly straightforward series of interactions because we can just reach into the database at any time and get the data that we need to fulfill the next step in the workflow. I mean, update the booking at the end. On a query, well, let's assume, I want to basically assume that we've built a decent monolith. Let's assume we've decided to go for a kind of CQRS model. We're not going to go through our entity model in the domain in order to basically get some data back. Like, for example, you walk in, you head up to the front desk, you want to check in, and I want to get up your details of your booking, the room reservation, and maybe some information from your account so I can determine effectively some personal preferences that you want set up for your room, or effectively make sure I call you by the right name. And in a simple CQRS model, I've just got some kind of query layer effectively, which I can then use to go and pull all the data I need out of the database, join it together and present some nicely prepared view back on screen for the user sitting basically at the check-in desk at the hotel. All right. So let's talk about how this picture changes once we get into the world of microservices. So first, a short version of what my definition of microservice would be. So I come from an SOA background, and I tend to think microservices is kind of SOA 3, SOA 2 was events, SOA 1 was web services. And it has some additional constraints coming from domain-driven design, from DevOps, even from things like REST and Gorilla SOA, which was created by Jim Weber. And all those have essentially created a series of additional constraints to help do microservices successfully. But I can think of a microservice as something that has the original 4 tenets. It has an explicit boundary. In other words, you can't reach in and talk to my data. You have to go via an API. The API could be HTTP, gRPC, it could be messaging, it could be AMQP, Kafka, etc. Right? And it's autonomous. That means I release everything inside this boundary together. Now, I also release everything inside the boundary together on a monolith, but here my system consists of a number of smaller pieces called microservices that are independently deployable, which means that actually I'm deploying a smaller part. And generally, a team is quite often oriented to owning a microservice. So the team now controls its own release cadence, and we get into great ideas like products, not projects. And we'll skip schema, not type, and compatible, not policy, because it's not important to this conversation. But we own and we're the single writer of that data. Nobody else can write that data. They have to come through our API to do that. And in terms of what partition strategy we choose, how many of these things do we get? I still am a believer in the kind of SOA approach, which says we're aligned to a business process, right? And so there are various ways of doing that. I have a separate talk, which you can see I gave at NDC London about basically capability mapping, but generally want to slice our system up into business processes and align these microservices with processes. So imagine this is what a hotel looked like in terms of slicing up on the business processes. It may not do, I don't know, don't build your fortune on this. So imagine we basically said, very similar to our modules, in fact, in our monolith, we had a direct bookings microservice, credit card payments microservice, accounts, housekeeping, and channel manager microservices. How do we now run those same scenarios we were looking at earlier in our new exciting microservices world? When we think about commands, by commands, what I mean is we issue some instruction or request to the backend microservice to update something, to change something, to carry out some work, for example, like making a hotel booking. One of the questions is going to become, how does that work actually happen? So this is a typical kind of layout I might have for a microservice. You can see we've got a bus down the bottom. So our microservices tend to be integrated by an asynchronous communication protocol using some kind of messaging transport. So Kafka, RabbitMQ, SQS and SNS, Azure Service Bus, whatever your flavor of choice is. And my individual services essentially listen for events on the bus. And that's how we've chosen to do most of our interop, because that gives us nice benefits like we're decoupled in terms of time and behavior from other parts of the system. And above them, I've got some kind of gateway layer. We'll come into more detail on what that is later, but that's some kind of layer which says I need to access potentially one or more microservices at a time. Okay, and I've got potentially partners and clients who want to talk to my microservices. So imagine that same scenario again, where I want to basically create a new booking for a hotel room. Well, actually now what's going to happen? I call the API to take a direct booking, but how am I actually going to start the work of doing the other steps in my flow? Getting my credit card information out of the account, taking the payment, reserving the room with housekeeping, updating the channel manager. Because direct bookings has its data about booking, but it doesn't have the data that lives in the other microservices. And the rules say I can't reach into their database and get hold of their data. So I need some other mechanism to basically to ask them what to do, or rather give them instructions what to do. So the obvious answer I might reach for is, well, they've all got an API, just like everything else. So I can just use their API from the client. So I could call my accounts microservice and say, well, give me the credit card details. And then I could take the credit card details and I could say, hey, credit card payment service, please take a payment on this credit card. It would then talk to basically the reserving of a room. It'd say, please reserve the room for me. And then essentially after that, I'd update the channel manager. Right. And that seems quite promising, but there are a couple of little details that we need to think about at this point. The first is we've essentially built an old school client server model. All of the business logic now lives in my client, not actually in my microservices. And that can be difficult because it means whenever I want to update my workflow, I have to update the client. My client has become smart and my actual services have become quite dumb. And this leads us to basically a problem called an entity service. We don't want our microservices to just be focused on entities. Okay? So if you create a microservice which is literally doing CRUD operations on a single entity or even an aggregate that effectively you keep updating, your problem is the business logic, which ought to live with the microservices, has now drifted out to the client. So if a team wants to effectively change how the booking process works in terms of their aspect of it, they may struggle. All they've got control over is CRUD. All the pressure is going to be on the front end team, which continually has to update the workflow whenever any changes happen in the downstream systems. So that top model, basically the entity services, is regarded as quite an anti-pan. And Michael Nygaard, the guy who wrote Release It, has a really good blog post basically about the entity service problem. And when I share the slide deck at the end, it's linked to the bottom, so you can go and read that. A much better model is to remember that our microservices are focused on processes that form part of our customer journey or part of our operational support for customer journeys. When we think about that, we can say, really what we want to do is have a new booking process which handles all the aspects of new booking and then effectively passes the torch onto reservations and passes the torch onto payments and passes the torch onto channel manager, so that effectively we have a flow of information through our system dealing with a booking. And then we can keep the business rules that apply to that particular process with the data for that process all inside our microservice. The other problem is if we think about it, we're going to make a series of calls here. So let's say our post takes a couple of 100 milliseconds, our get 100. Our credit card payment takes a lot longer because essentially we have to make a call to an external payment provider and they usually take forever to basically service our requests. Housekeeping, well, we're just doing a quick post, maybe that's okay. And channel manager, again, we're in this world where essentially we're probably making an external call to Expedia, Booking.com, we may be making a series of calls, and effectively the latency is going to build up. And so for our individual user sitting in front of their computer or on their phone looking at the client, there's going to be quite a wait. And if it's in a browser, we're going to be the people who put the message up saying, please don't navigate away from this page, right? Now, we might say, well, some of these operations can be done asynchronously, but we've still got an end-to-end process to complete here, which is being run by the client. So that, again, doesn't seem like the best solution for us. All right, let's switch to a track and look at the problems we're going to get with queries in our microservice world. So just park your thoughts about commands. We'll come back and we'll explain how we solve some of those problems in a bit. But now let's basically have a look at queries. What are the problems we get with queries? Well, queries might seem a lot easier. So let's say essentially you turn up at the hotel and you go to the front desk and you say, my name is Mr. Cooper and I should be booked into this lovely hotel in Portugal because I'm staying here for NDC Porto, and a lovely crew at NDC will have booked me into my Portuguese hotel and they look for my booking. Then the system is really going to have to go maybe probably and talk to things like direct bookings, accounts and housekeeping to get that data. And this seems much more straightforward. I can just use the API to get hold of all the data that I need in order to basically service your request. But again, bear in mind that effectively I've now got a considerable amount of latency in calling that request. Is there a better way of doing that? Is calling all three of those services and basically me then as the client taking all of that data and munging it together myself effectively before I can display it? Is that the best approach, or are there other alternatives which would be more efficient? And again, we'll talk about those. And overall, I think of this problem in a microservice, I sometimes abstract it as calling it the join problem, right? Before, we had a single database, and it was really easy for us when we were querying to join data between two tables in order to basically produce something like that said Ian's booking information for the front desk. Once we get into a lot of microservices, because every microservice is now managing a portion of the data that we hold, joining now becomes harder because we're actually doing that basically via HTTP across multiple microservices. All right, so let's have a look at some kind of solutions that we think we can use to solve some of these problems. So we'll start with reads, and then we'll move into commands. Now I drink some water. Okay, right. So here's that kind of model again. When we talk about a gateway layer, I'm going to talk about a number of things as being in the gateway layer. So when we talk about gateways, particularly API gateways, some of us tend to think to ourselves, oh, that's an off-the-shelf product that I can deploy in AWS that essentially sits in front of my service, etc., and does some load balancing and routing. And I want to avoid that kind of concept. Gateway for me here is basically acting as a layer that sits over our microservices and manages essentially some of the interaction we have with that. So we'll ignore process managers for the time being, just focus on kind of API gateways and BFFs on that level. All right. So what happens when I check in? We said when I check in, I'm going to want to go and get some data, right? And I'm going to probably want to go and at least check on the account information, get some of my personal details back, perhaps even the credit card I've got on file so they can check with that. And I'm going to want to check with the housekeeping system about my room reservation. And so naively, we might just say, well, the simple answer here is that I essentially just call basically accounts and housekeeping, right? Effectively, and I say, maybe I start with basically accounts, and I say, go and find Mr. Cooper's account information, and then see what bookings he's got. Here's one for the day. Or I could do it the other way around and say, let's go and look for reservations on this date, and then I'll pull in the account details for the matching account holder. Well, we might think, what I'm going to do is just compose that information basically in 2 calls. I could, but there may be another alternative. And that is that rather than making that other call, I could potentially just return it in one API call. And this comes up a lot, particularly when people start to compare REST with GraphQL. People say, oh, the problem with REST is I always have to make multiple calls because my REST-based service only owns data for kind of one microservice. And that doesn't necessarily have to actually be true. So let me take you through the journey of an idea called reference data. So reference data is an idea created by Pat Helland. Pat Helland was an architect at Microsoft and at Amazon. And Pat wrote a number of papers which are very useful for understanding how to build successful service-oriented architectures. But what we need to understand for the point of view of reference data is that we said earlier that my service essentially owns its data. And it's the single writer of that data, and it has an explicit boundary. But the reality is, when I call that service to say, get some booking information, data leaves my service and travels outside of it. There is now an on-the-wire piece of data which refers to something inside the microservice. And it has a number of important characteristics, right? The first is that that data essentially is stale. As soon as it leaves basically that system, it becomes stale, because someone could come in and update the booking information, and my consumer working on effectively the get that they've got previously has slightly out of date data. So quite often what we tend to do is have some kind of version or timestamp on the data so we can tell how current it is. This should actually say the last modified rather than the modified since, really. But we're saying basically, here's a date and timestamp that's produced that, so you can check on later and see if you've got the most current one. And cache control would be an indicator for how long we thought it was safe to keep using this version before it was likely someone else had updated it or changed it. The data left. It's also effectively immutable. There's no point in you changing the information you get back as a result of the GET request. It doesn't actually update the booking information. The only way to change the booking information is by an API call to the direct booking service itself. And that data doesn't have to be HTTP messages. It could actually be an event that I've raised. And that event itself may have some information on it, and that may include things that, again, like the version basically of the booking information just received. All of that data we tend to call the outside data, and we tend to call the data inside the service the inside data. Now, the really interesting thing about outside data is it's highly cacheable, both i.e. from it comes from basically a GET, which you're used to caching, but even information I pick up via messaging from another system is also very highly cacheable. And we talk about this more in the event-driven collaboration talk, but the idea to think about here is this. If I was to call the accounts system regularly to get your account details, I might think to myself, I could cache that API call and store your account information so that effectively next time I needed it, you'd be able to get hold of it. The trouble is, of course, generally speaking, I might have to visit a given hotel once, twice a year. And so it's very unlikely I'm going to get cache hits, basically, when you turn up at the front desk. But if I could pre-build the cache such that effectively when you turned up, your data was already in the cache, well, then that might be a way of avoiding me having to make the call across to the account service. And so this leads to this idea called event carried state transfer. I think Sam Newman actually calls it a data pump, and I've also seen it called reference data by Jim Weber and in Robinson, their book Rest in Practice. And the idea is that what I could do is listen to events from the account system. And I assume that the account system produces an event when anything changes in the world of accounts. So, for example, I change my address, I change my credit card to update it because the old one basically was out of date. I change my name, for example. Whenever any of those happen, what happens is housekeeping is listening to those events, and it's building in a cache of information it needs about accounts. So generally speaking, it's probably storing my postcode, my credit card, etc. details. And it's able to keep building up that cache in response to events. And that means when effectively housekeeping basically is asked, well, can you get me the account information that's attached to it? Can you get this reservation details? It can actually attach account information to that reservation. So rather than simply having to go make the second call, it can say, generally when we get a reservation, we also tend to give you the last 4 digits of the credit card, the customer's postcode and date of birth, so you can check it's really them by asking them a couple of simple questions when they get to the front desk. And I can return that in the original response. So I'm now only making one call. Very common use of this is if I store product IDs and I want to attach the product description. So I work at Just Eat, some of you may know. So if I've got a menu ID attached to an order and I want to attach basically the description of the menu item, if I had a local cache basically of that menu data, I could then attach the relevant description rather than calling a separate service to obtain that data. And I can read that customer info. And that means I turn that into a one call rather than essentially two. All right, let's have a slightly more complicated scenario. Let's say what I want to do is measure the effectiveness of my given channels. So what I want to do, I'm a manager sitting there and I'm trying to find out how much I sell through Booking, how much through Expedia, how much through Google, and whatever the services are that the aggregators. So probably what I want to do is look in my system and say, hey, find me each channel, group for each channel, the data that belongs to the individual bookings, and give me a summary of how many bookings I had per quarter for each of those channels. And again, naively, my approach might be, well, I'm going to call the channel manager, get a list of channels back, and maybe I'm assuming my booking information has an ID of a channel that basically made a booking, and then I will pull back the list of bookings, and then somewhere in my code, I will essentially do all the grouping of that data between the channel manager and bookings. Don't forget, whereas previously I might have done this by querying my database and relying on SQL to actually group up all the summary information for me, at this point, if I'm doing it in the partner, it's going to be client code running in the partner that effectively has to basically do all the grouping and take all the booking information and spit out the report. And that seems kind of ineffective, right? Because essentially I've moved all the business logic for creating that report out to some consumer of these two APIs. So what can I do to solve that problem? Well, the answer looks very similar. So if I take this notion of event carrier state transfer, I can say, well, hang on a minute, my booking service and my channel manager service are constantly creating events. So if I add a new channel manager or remove a channel manager, etc., then effectively I'm going to have an event. So I could listen to those and come up with a list of channel managers. And then when I see a booking, I could say, well, when that booking comes in, I'm going to basically aggregate under that channel manager the number of bookings that have been made, total value of the bookings, etc. And I can do that per quarter. So I'm listening to those events, and over time, I'm building essentially a database that gives me the reporting information I need. And that channel vector database can be written such that effectively my query from my API is a very simple call that probably just reads a row out of the database. So it's very fast and efficient. Some folks call this a composite view model, where essentially we are building a model that can answer given query questions for a consumer. Pat Hill in his discussion of reference data refers to this as historic artifacts. When you think about something like a data lake in your enterprise, quite often data lakes are just really large scale versions of this, right? So your data lake is quite often listening to all the events that are flying out of your microservice and building a complex model in order to do analytics against. But even at a really simple level, it can help you essentially build responses to particular front-end queries. Okay, so it's a really easy one to do, and it's very effective at building fast report type information. And again, when people talk about GraphQL versus REST, one of the things they miss is that if you understand what report you're going to build, it's very easy to do that with REST, provided you can kind of pre-build the data that you need to answer the question with. Oh, we have some fancy animation. Behold my animation. Hear me. Okay. All right, quick glass of water. All right. let's imagine a final kind of scenario, and I'm going to basically push this scenario a little bit just so we get a different example. Let's imagine I want to basically search for going to stay in Portugal, and the particular hotel brand I pick has 3 or 4 different actual hotels in Porto. And imagine there's like Radisson has Radisson Blue and different, it's got a budget entry, it's got a luxury entry, maybe it's got some boutique brands, etc. And I'm going to their site and I want to know what's the range of things that you offer me. Okay, so I'm typing in some information saying where I want to go and visit, and I want you to give me answers across all your properties. And let's imagine for the minute that the nature of this information is fairly real time, because there's a big conference happening in Porto, bookings are happening rapidly, and it may well be that I want to get up to the minute information. The thing about the last example we saw, the composite view model, is that tends to be often used where the flow of change is sufficient. You're probably talking about a roll-up that happened. Doesn't matter if you see data that's basically, a little bit old by eventually a few minutes or so, because messages are still in the wire, because generally it's a position of data that is indicative rather than has to be exactly right. So imagine here that the data is changing very fast. Now, actually, you can use the composite view model to solve a lot of these problems, because you're probably processing your data fast enough to keep updating your position for a group search. But let's imagine we can't. Let's imagine the product manager has essentially put his foot down and said, no, I must have near real-time booking information. So in this particular case, the problem I've got is that I need to go to direct booking and I need to go to property services, but I can't pre-build the view of what I've got. And this tends to be where you really do need to do actual composition in a gateway layer to say, I'm going to call both these services, and I'm going to combine the data together. So what we do is have some kind of gateway API that essentially says, I provide the API for hotel group search. You call me, I've got my own REST API I've written, and I will internally then make the calls to direct booking and property services, and I will then manage the data together to show the customer by whatever criteria they put in, basically what hotels are available right now in Porto, given they said they don't want budget, they only want luxury and boutique hotels, explain it to them now. So why is this kind of gateway layer? Well, if you think about people like Netflix, when Netflix originally were the kind of pioneers of this kind of model, this API for Netflix was written in Java, and their Java API effectively sat over their actual fine-grained SOA, their microservices, and made the calls directly to them. And so this layer acts as the one that gives the API that basically joins data across multiple microservices. Now, as I said before, I wouldn't go to this if you can solve the problem. It's just a simple problem of what we need to have is some additional operand data, which just says, what is the customer's address? What is the customer's credit card number? I do that via event carrier state transfer. And if I needed a composite view model, I could pre-figure out the query. I might well do that. But this model says, I'm going to do it in real time. I'm going to call multiple services and compose the answer. And you can think of this basically layer as a proxy. It's a proxy that sits between you and the microservice API and manages those calls. And that has some kind of interesting characteristics. It's not just usable as a composite API or a BFF. So a BFF basically really, which is Sam's term, BFF is really one of these, but it's built for a specific client. So a BFF says, actually, I'm going to build one of these, but it's going to return data in just the shape our Android client needs it, or just the shape that this third-party organization wants that data, as opposed to an API gateway generic, which is basically just a generic gateway that I can use for any number of clients. The reason you might do the more tailored version is to basically make sure that you're not returning unnecessary data to the consumer, so you can minimize the cost over the wire. And given this piece of data, given this proxy layer in a gateway, I could say, well, to be honest with you, I could put some other things in here. So this is what Netflix did with Hystrix, right? It said, you know what, given that I'm now temporarily coupled to any of these microservices, It's possible that I get some transient network error talking to them via HTTP. It's possible that for some reason the instance the load balancer sends me to initially is bad, and I failed to tell Tech I need to go to another one. And I can do things like do a retry. I can circuit break basically to stop going to things that are bad for a temporary period. And maybe when I do that, I can serve cached results because maybe the hotel bookings haven't changed fast enough that I don't have to worry about that. I can rate limit here. I can say effectively I'm getting too many requests because everyone wants to travel to Porto. So I'm going to tell my clients to slow down with the requests I'm receiving. I can load balance at this layer across a range of available instances. So this is where we tend to get into the notion of API gateways as a product that are doing something, because I can have all these useful additional properties that I start managing at the layer of the gateway itself, which are kind of slightly orthogonal to its role in being the place that's providing a new API, which makes calls to our microservices, but actually become part of the requirement for you when you start to say, I need to call 4 or 5 microservices to return the result. And therefore, I have a more complex problem of saying, well, I'm now dependent on 3 things. So the availability of my service is dependent on the multiplication of the SLAs of all of those 3 items. And so I need to manage that result more with things like retries, circuit breakers, etc. All right. That's talking about reads. So roughly just kind of remember the event carrier state transfer can help you solve a lot of problems by effectively either letting you bring in the additional data you need to make your request slightly more informative, or it lets you build ahead of time some kind of composite view model to answer the question. If not, you may need to go to kind of composition at the gateway layer. What about conversations? What about writes? Okay. So imagine that I want to now handle a command with this architecture. So I want to basically create a new booking. And we looked at that. That was the kind of first example we looked at in our model. So I'm saying, hey, a new booking comes in. I'm going to write that basically to my direct bookings. And bookings is going to then raise a message because we've got nice asynchronous communication between our microservices saying a new booking has been made. And what we want to happen is that the customer gets charged for that information, charged for that booking, and then we basically reserve the room in housekeeping and a channel manager. But what happens now, effectively, if I try and take the payment? The problem is going to be that I end up in a world where the credit card payments doesn't have the account details for the customer to get the credit card information. So how do I get hold of that credit card information? Because the booking has just come in, right? On account, and I don't seem to have it. How would I get hold of it? And naively, what happens in a lot of people when they're discussing kind of how microservices work is they say, oh, once you've received the notification it's a new booking, you would make a call to accounts via accounts API to get the credit card information, etc. that you need. The problem with this is that earlier on we said we wanted a nice asynchronous communication between our microservices over the bus because we wanted some benefits of decoupling both temporarily. In other words, the other source doesn't have to be up, and in terms of behavior, we don't have knowledge of all the other calls you have to make. But we just recoupled as soon as we try and reach into accounts to get hold of that data. So how do we solve that problem? So there are 2 main solutions, and we can think of these basically as both being push models. In the left-hand side, we can see a model where we're saying, well, the obvious solution would be to make sure that the time that we message reaches credit card payments, we have all the data we need to make a payment in that message. All right. And so the question is, well, how do I get hold of that data? How do I get hold of the credit card data from the customer's account to pass the credit card payments, basically, when it comes in? The second option is I have some kind of cache of the account data. So if the credit card payment simply says, I can answer that question myself. I already have the credit card details for the customer. Okay. So look at how I solve both those problems. So choreography is the name we tend to give to the idea of having a pipeline through which a message flows. When we receive basically a request to do something, we flow that particular request through a pipeline of services that all take a hand in delivering. Why is it called choreography? Well, I tend to think of it this way. When people perform a dance, essentially, a choreographer is there beforehand and helps them basically figure out what the dance will then look like. But in the actual performance, the choreographer is not really present directing things. The dancers essentially are on their own. And in the same way, while you may design at design time the actual relationship of all the events that are going to flow through your system to make work happen, in this particular case, the customer journey of making a booking, there's nobody actually controlling that process in this model. And what we do is we simply look at the good old pipeline approach, right? So a pipeline essentially says I have a source and a sink. There's someone who originates the actual workflow, someone basically is the final step in the workflow, and in between I may have an arbitrary number of steps that I pass through. Okay. And this is a very common approach in messaging, is to use pipelines to solve problems. So my direct booking comes into my direct booking service, and it doesn't have the credit card details that I need. But what actually listens to direct booking made is going to be the account system. And the account system, when it picks it up, is going to say, I know that when I receive a direct booking is made, what I do is I enrich the content of that message with credit card details. We tend to refer to this pattern as a content enricher. It has the credit card details, and it may raise a message saying, for example, new booking with credit card details. And that's what credit card payments then listens to, is that other message, which effectively means it now has basically the booking details with the credit card information it needs to take the booking from the customer. And that pipeline approach of enriching the data such that the person that needs to action it is actually quite a common way of solving problems. Okay, so what happens if there's an error in this model? What happens if credit card payments basically can't be enacted? Because errors in pipelines are an additional problem with pipeline architectures. What happens if I get an error down towards the end? Well, the simple answer with choreography is that credit card payments microservice raises an event saying there was basically insufficient funds or whatever error, or credit card has expired, and it raises a credit card payment error. And new bookings essentially can listen to that error and say, hey, there was an error raised against the credit card payment for this booking. I'm going to suspend the booking. And then it may in return now say, hey, when I suspend a booking, what I do is issue a message so that effectively we can begin the process of contacting the customer to ask them to present new card details. And so I'm going to raise a message that goes to accounts so that accounts can enrich that message with the customer contact information, and that can then appear effectively via another service in somebody's inbox to actually action calling the customer and trying to basically get a new credit card details, or even sending an email to the customer to ask them basically to represent their credit card details in a certain time frame. And that's choreography. And the real advantage of choreography is that we retain this event-based model. And the event-based model says, I, as the publisher, have no awareness of my subscribers. I simply know that effectively my job is to publish these events and that other people take action. And that means we have a lot of decoupling between our systems. Right? The disadvantage is that it's very hard for anyone to understand what state is this booking in. That's a traditional problem with the pipeline architecture. You read about classic pipeline architecture patterns. One of the things that comes out, people say it's pretty unclear from the point of the feedback to the user at what point in the pipeline their particular request is. Now, an answer in pipeline architecture is something called a wiretap. So a wiretap says I sit and I listen to all the messages flowing down the wire, and then effectively I can keep updating what state the order is in. Where has it reached? Oh, it's currently getting the account details. Oh, it's reached credit card payments and it's trying to take credit card payment. Oh, it's raised an error and basically the booking has been suspended. And generally that piece of data, you just wrap an API over it effectively, and somebody then basically in your help desk can always then dial in with the booking ID and figure out where the given basic transaction is, right? And for example, at Just Eat, that's very common way of us figuring out where your order is. But if you're kind of unhappy with that model of just having kind of some monitoring going on, you may want to move towards orchestration. Orchestration, another couple of benefits to talk about in a second. So orchestration is the model that there is a conductor. There is somebody controlling the whole orchestra as they begin to actually move through through this journey of conducting work. And so with orchestration, I may use this idea of a process manager. Now, also folks call it Saga. We don't really get into whether Saga is a good name or not. Saga, and particularly in the .NET community, is the word everyone tends to use for this. But essentially, I'm running effectively something that has multiple steps that I need to process. Generally speaking, for me, the process manager essentially always lives outside the microservices, right? Some people put it in the initial microservice. I think the problem with that is you move the workflow into one microservice is a bit of a lie. You have effectively externalized some of the workflow. And so what happens with this model is the process manager basically gets told, we're going to make a booking. The process manager effectively stores something in its database which says, I am now running this particular booking workflow. And it has an ID for that. And then it sends a message, right? Generally, basically, you can use messaging to do this. You don't have to basically use HTTP. You can use a request response pattern in messaging. And what happens is I send a message to bookings and I say effectively, hey, I've got here's a new booking request. Bookings goes away and satisfies that, makes the booking. And then effectively what it does is it responds to me with information about that booking. What tends to happen is I tend to give you a private channel to reply on. I'm not interested in everybody listening to booking responses. I have some private channel. Quite often I advertise the address of that with whatever format I'm using, AMQP or an SNS endpoint topic, and say, okay, you should reply here. And then effectively you reply back with another message, and I pick that up. And when I pick it up, I say, okay, what was the particular booking workflow that I'm interested in? I weight that up and look at it and say, okay, I've now got the direct booking. The next step in my workflow is to gather the credit card information. So again, I send another message towards basically the account system, and I say, please, can you give me back the credit card details? And then again, effectively, it then raises a message saying, here are the credit card details for this particular booking workflow. I listen to that. I wake up my particular workflow and I add the credit card details to it. And you can see in the top left-hand corner, we refer to this as command-oriented rather than the previous one, which we refer to as event-oriented. That's because our process manager tends to know that this particular system it's talking to is going to handle those messages and give it a response back. We have much tighter coupling here between the process manager and the individual steps that it's dealing with. And then finally, what may happen is basically I say, okay, let's basically send my enriched booking message, which has the credit card details, etc., effectively to this, takes a payment, right? And I can take the payment, that comes back, another workflow effectively says, great, I am now done. I have reserved the room for the customer. And in return, probably what it does is essentially it then says, I'm going to now update basically direct bookings and tell it basically, which we're not showing here, tell it basically to mark the booking basically as complete. What that gives us essentially is a view of the process the whole time. We can always ask the process manager what state it's in. Now, we haven't really got any significant advantages at this point over using choreography, and we've actually got more coupling. So why might I want to do that? So generally, it's to do with how we manage errors. In the choreography model, what happens, for example, if I can't take a payment, is that my credit card payment service raises an event saying couldn't take the payment. But there's not necessarily a guarantee that we're going to actually basically terminate that booking, because I'd have to rely on the message having guaranteed delivery to basically the booking service to pick it up and get hold of that information. I'm just raising an event. I don't even know if there's a booking service that's going to listen to it. So in circumstances where I want to guarantee that my booking is actually going to get reversed so other customers can now book that hotel room instead, the advantage of a process manager is that essentially it gets the response back saying I failed to take basically the credit card correctly, and it will keep retrying to tell the direct booking service that, hey, you need to cancel that booking. Right, and then it in return can then basically send a message out which basically says, hey customer, please represent your new credit card details. So in other words, if I require quite strong guarantees around basically the compensation flow, I may end up with basically using a process manager. And really it's a business decision as to kind of what happens. Interestingly enough, I was explaining to some people the other day that Just Eat, for example, what happens is because we don't control all of the delivery, some of it happens by individual restaurants, some of it happens by third-party couriers, only a small proportion of it happens by our own couriers. And even then, even when it's our own couriers, we can't guarantee they're always going to press the button. So we quite often don't know whether food's been delivered to your house, right? And so what we actually do is we assume food has been delivered if we don't hear after a certain point that food's been successfully delivered to your house. Why would we do that? Well, because you'll tend to phone us up and complain if you haven't got your food. So we don't really need this kind of guarantee of some kind of process manager because we assume by the business process that a human being will actually deal with that for us. Okay. The other kind of model that essentially process managers are particularly useful for, and it comes into play quite a lot in the hotel industry, is the reservation pattern. So the idea with the reservation pattern says there's a lot of demand for rooms, and I want to make sure that I don't have some room in some kind of suspended, we didn't take a payment state for long. I want to make sure that the transaction gets completed, or else we make the room available to somebody else. And so typically what might happen is the user's making the booking, and when the booking starts, we start a kind of a timer. So generally there's some scheduler that's running the process manager which says this booking ought to have completed in this time frame. And as we go through the rest of the process, if for some reason we get a failure to actually basically reach the end, perhaps, for example, we didn't get all the details we needed from the customer to complete the credit card payment portion of the work, then we can time out that given transaction effectively and then reverse the booking. And that then frees that booking up for somebody else. So if you try and buy tickets for basically, the movies or effectively for a concert, you'll quite often encounter the reservation booking and you'll see a timer on your screen saying, hey, you have 10 minutes to complete this. And again, process managers can help you run that. One thing to be wary of with this model is that we are potentially, as soon as we use orchestration, back in the model of an entity service. You can obviously see how easy it would be for all of the business logic to end up now clustered in the process manager and for us just to have entity services again, which basically we're done. Okay. And this is the problem in what we would call SOA2, which is often described as the enterprise service bus. We had these tools like BizTalk, for example, that sat in the middle, that had these workflow tools that could manage and build workflows and run rules and individual logic. And what happened was they became the center of our universe. The universe was basically hidden away inside some vendor-based product, and the individual services we were building were very dumb. And this is where this expression smart endpoints and dumb pipes you'll see comes from, which is referred to in Martin Fowler and James Lewis's article ThoughtWorks over microservices, from this idea effectively that the business logic is creeping away into the enterprise service bus. And really it's an expression of this same idea. We don't want CRUD-based entity services. We want services that are based around processes. We want that flow through. You'll tend to find if you stick to choreography initially, you're more likely to end up in the pit of success on the bottom half. And if you move to orchestration, just be wary that it can lead you into the dark side and you end up on the path towards an enterprise service bus model. Okay, so caching reference data. So let's this one to kind of last because we've explored this concept already. And it's also much more, a lot of the gotchas in this and the detail is explored in my talk on event-driven collaboration. But we could simply effectively build a cache of data via event carrier state transfer, which contains the necessary credit card information from the user's account so that credit card payment can access it at runtime. And the accounts information then essentially is the accounts basically say credit card details have changed, customers changed their address, customers changed their surname because they got married or whatever, and that's very traditional. Then essentially when the credit card payment comes in, we're able to effectively read from the accounts database to get that credit card information that we need and take the payment. Right? And that's a very simple model again with event carrier state transfer. And typically what we have what you call shared collection data. So that's data where effectively large parts of our system tend to access it. Account data, say for example, Just Eat's restaurant information. It's very common to replicate that so that essentially you can just grab it if you need it in order to complete the work in response to you receiving basically an event. All right. There we go. And in turn, you may raise your own message and someone may listen to that downstream. Consumers. Right. Oops. On. Click. The next page. All right. So yeah. So as I say, basically, if you want to see, so there's some more details to understand around event carrier state transfer to do with basically things like producer consumer correctness, where you get into outbox pattern and log tailing, etc. Please do go and see my event-driven collaboration talk, which you should be able to find on NDC's list of videos. And I can always dig it out and share a link in the Slack channel after this. And with that, we are done. I've got a couple of minutes for questions, and I will hang around in the Slack room afterwards when I disassemble my studio here enough to actually better sit in front of a computer rather than have to stand for the whole time. But if there are any questions, I need to try and find the chat. I have so many windows open. Let me kill the presentation, and then I can probably find the chat window if I'm lucky. I'm going to be stumped by able to find chat here.
So the question is, I'm reading, is how to make sure the process manager does not turn into a monolith.
So how do you make sure a process manager doesn't turn into basically, yeah, a horror show basically, and it all becomes a whole distributed monolith? Well, not if that becomes centralized logic in your process manager. I think the thing to do usually is process managers work particularly well inside a given microservice boundary. And the context we're talking about there is it's not uncommon necessarily to, within inside a microservice boundary, say have a container that basically has your API in it, a container that has some worker processes inside it that basically you're offloading work to. And if it's basically within the domain of a single process itself, they work pretty well. As soon as you start to cross multiple microservices with them, you need to start being cautious. And generally, it's kind of okay if it's a fairly straightforward, really what I'm just trying to do is run a timer on a reservation, or really I'm just trying to make sure that I'm ensuring that basically the reversal of the compensation for a failure route, it will be enacted and effectively I'll get retries. If you start to do things like write conditional logic in there, or you start to have too much knowledge around a complex set of interactions and multiple microservices, I would start to be cautious, particularly if you're doing things like making calls to external systems from within your process manager rather than letting your microservice do that, etc. I would start to be pretty cautious. My usual model is start with choreography and only move to a orchestration if there's a problem with choreography's compensation or needing reservation pattern that I can't solve successfully with choreography. I would always make that my default, use events, and then I use commands if effectively I really can't solve the problem that way. And that's not a great answer, but it's kind of like, don't go there unless you know that you're going to pay a price in some behavioral coupling in your system, which will create more rigidity for you. Anything else? Can't quite figure out how to see whatever I've got on my screen. It's not showing the chat window.
I can read the question for you, Ian, if you want.
Yeah, cool.
So from Bernardo, in your opinion, what is the best technology to build a gateway?
Best technology to
build the gateway.
Build a gateway. That's a really good question. It all depends on your kind of platform. So there are different types of gateway out there, right? So Just Eat effectively has got Kong, which works for some things. It's kind of Nginx on steroids. But if you really want to run actual code in there, you end up in Lua, and it's not particularly fantastic. in Java land, you can use things like Hystrix, etc., effectively in that layer, and that's a pretty good solution. In .NET land, you can get a long way with using something like Poly inside basically an API layer, effectively, to do a lot of that work for you. You're effectively adding a proxy, or do retry circuit breakers, failovers, that kind of thing, etc. You may need state machines in there effectively. If you're unlucky, you can just get a simple technology to do that. You can, if you want to do lots of composition of APIs, there are things like Apollo using GraphQL, which can basically let you combine various REST APIs together to do work that way. We're not really used Apollo in Anger, but it looks very interesting. And GraphQL looks very interesting, a choice for doing genuine composition across multiple microservice APIs in an interesting way with technologies like Apollo behind it to back making those calls to the multiple microservice endpoints. But in terms of a proxy, you build an API and use it to proxy underlying internal APIs. Honestly, you can just use anything that basically in your platform supports building an HTTP-based API, and it has logic to support packages that support things like retry, circuit breaker, fallback to a cache, etc. All right, suspect we are close to time. I could probably do questions in Slack. At that point, I haven't done. I've got a clock on somewhere. All this technology, and none of them gives me a clock. I got 4 screens, and I can't see a clock or the chat window on any of them. So that's basically a bit of a fail somewhere. All right. I'll tell you what, guys. I will see you in Slack because I expect we're probably towards the end. I will give me a couple of minutes to get into Slack, and I will get in there and start answering any questions you've got in there. I'll see you then. Thanks very much for coming.
Good morning, good afternoon, good evening, wherever you are. I don't know where you are, but I'll tell you where I am. I am on the East Coast of the United States. My name is Carl Franklin, and I'm here to talk Blazor. And the slide deck that I'm using is actually from a series that I've been doing on YouTube and Twitch, sponsored by DevExpress, called the Blazor Desk Show. It's normally a 2-hour show. I'm going to bring it down to 1 hour. Hopefully I can cram everything in 1 hour. I'm sure I can. So let me just get started with the agenda. The agenda is I share everything I know about Blazor. You sit back and enjoy. And by the way, all of the materials for this is online at blazordeskshow.com. So you can just go ahead and download it there. First of all, is everything working? Can everyone hear me? Is everybody in the Slack channel and all that for Conference Room 1? You probably don't want to use the chat window here. So that's probably not a good idea here on Zoom. If that's where you are, I'm not even sure. All I know is that I'm at home and I'm broadcasting to you. So I'm going to be monitoring the Slack channel. Hi, Dylan. How you doing? Wow, we got all sorts of people coming in. All right. Good morning, good afternoon, good evening. I am Carl Franklin, and I'm going to be sharing the next hour with you talking about Blazor. So first of all, just make sure everybody has everything going on. I'm in the Slack channel, Conference Room 1. I'll be monitoring that from time to time, probably not. And this is not .NET Rocks. That's my cup. .NET Rocks is. Woohoo! Okay, that's the .NET Rocks we have today. This is the Blazor deep dive. Blazor server deep dive. So I'm going to share everything I know about Blazor, and mostly server-side stuff, because there's some unique challenges here. As I said before, you don't have to have FOMO, because
So apparently when I joined this meeting to check it was okay, it decided I was in charge. And then when I left, it just closed the meeting for everybody without prompting me. Hey, Carl. Sorry.
Hey, what happened?
When I joined, it decided that I was the king of this meeting. And then when I left, it assumed you all had no reason to be here. I am going to make you the host of this meeting. You have the power.
Oh, awesome.
It is yours.
Great.
You have the mute button. And I am now going to drop
Thank
that
you.
And check how it's all going. Have
so
fun.
Wait, before you go,
Yo.
Does that mean that are people connected directly to the Zoom meeting? So there's 2 people in the audience right now, Shahid and Raquel?
I can see there are 12 people connected, but most of them have their video switched off.
Oh, okay. All right, good enough.
Yeah. 13.
Me. Again, shall we? Thanks, Dylan.
Have fun.
All right, so here's my gratuitous graphics of the day. Welcome to the news hour. I'm Carl Franklin, and this is some really cool software that I have called vMix, using to stream Interestingly, I've turned my company, Pwop Studios, into a streaming production company. So you want to do what I'm doing right now without having equipment, maybe just a green screen and a webcam, and do conferences. We can do all of that for you. Enough of that. Let's get started with Blazor Server. Here's the agenda. I'm going to show everything I know, everything I know about Blazor in an hour. And lots of audio drops, you say. Interesting. Let me take a look at my streaming settings. I don't think they've changed since last night. Audio outputs. Yeah. Yep. I'm sending good quality audio to Zoom, so I'm not sure what happens to it after that. But audio. Here's and be prepared to drink from the fire hose, but don't worry about the FOMO because you can download everything that I'm showing you here, including to recreate everything. Explains everything at blazordeskshow.com. I originally did this talk for the Blazor Desk Show, online talk. For that, so initial stuff, you know, what is Blazor? I think everybody knows what Blazor is by now. It's more than just running C# in the browser. It's a component model where the markup code will run equally well in two models, in the browser on WebAssembly and on the server with a little bit of magic. And magic is what we're interested in right now. We're going to talk about the upsides and downsides of the server model as opposed to the WebAssembly model. You really don't want to combine models, nor would you want to. You have to, before you build projects, when you create a Blazor project, it's going to be a Blazor server project or it's going to be a Blazor web. You don't combine the two models in one application. And here's why. This is a SPA framework, okay? So like most SPA frameworks like Angular and whatever, this is a way that you do binding from UI to code. And it's a way that the UI, in this case, the DOM, interacts with the code. And so the server model essentially puts this SignalR hub in between the browser and the server, and all the UI is traffic, or all the UI plumbing is done over that SignalR hub. More about that in a minute. I don't want to go into the whole Silverlight thing because that's really about WebAssembly. So here's the magic. As I said before, the persistent WebSocket that happens with Blazor Server, it's all SignalR. SignalR is in there, right? Baked in to .NET Core 3 is this SignalR hub. And you don't have access to that SignalR hub. You have, you don't use that for your own kind of communication, you know. That's just there for if you want to add your own SignalR hub, you can do that, but you certainly don't have to the one that Blazor is using. And I'm really sorry about the audio problems. Maybe we could just take a minute to figure that out. 1 second.
So, Carl, first thing
that better?
Just gonna check. We just want to check whether it's only your audio
better?
source.
1, 2, 3.
Keep talking.
Had
Give
a
us
little
like
lamb,
20 seconds of dialogue.
Dylan, I can't hear you. Oh, that's probably why, because I turned that audio off.
Okay,
Is that
so
better, Dylan?
just give us about 20 seconds of audio. Just speak for a while. It's a little bit intermittent. It's cutting in and out.
Okay. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now we know our ABCs. Happy, happy shall we be.
Yeah, that
Won't
sounds
sing
pretty
your
good.
ABCs?
I will consider. Yep, I think we sorted it. Whatever you did, leave
All right,
that.
great. Excellent. So as I was saying, the magic of the server-side hosting model is the SignalR Hub. And that SignalR Hub is there not for you to use for your own SignalR purposes, but it's there built in just to handle the communication between the browser and the server. So unlike MVC or ASP.NET Web Forms, or any kind of web application, really, just simple HTML and JavaScript, AJAX stuff, what usually happens is the JavaScript runs, and when it wants to call into the server, it makes a call. Like even when you just click a link or a button or something like that, there's an HTTP client, HTTP request that is sent over port 80 to the server. The server gets that request, packages up whatever needs to be sent back, sends it, and then severs the socket connection. So you have lots of little connections opening and closing, and that's really good when you know, for a web server that has to handle multiple clients and connections and all that stuff. But this is a little different. Oh, good. I'm glad. It's great. This is a little bit different. The SignalR is usually an implementation of WebSockets, and I say usually because if WebSockets aren't available, it sort of downgrades to other technologies like long polling. But WebSockets is an implementation of sockets that the web can, websites can use over port 80. And just like all sockets, when you make a connection, it stays open until somebody severs it. Either the client disconnects or the server disconnects in the case of HTTP. This isn't HTTP though. This is a long, persistent connection, right? It stays open essentially for the life of the session, whatever that is, right? As long as the client is connected to that SignalR Hub, that connection stays open. And that means that the server can send, push requests to the browser, which is great. And the browser can send, information to the server as well. So here's what happens. Actually, I'm going to show you what happens. Let's not talk anymore. Let's just pull up Visual Studio here. I'm just using Visual Studio 2019, but this is a preview version. The reason is because I was doing some WebAssembly stuff as well. But I'm just going to create an app called Blazor Server. And let's make sure we get this in the right directory where I know there isn't one already. Because I've installed the Blazor WebAssembly template, I have the option of doing this, but that's not in the box currently. You have to do some extra stuff for that. So I'll create a Blazor Server application. And right out of the box, you get this nice little demo right in the template where you have a few pages. You have a static index page. You have a counter page, which is a little button label interaction, and a fetch data page, which sort of shows how to get data from a service. So let's look at counter as I bring this up and run it, and just take a look at the magic that's going on here. All right, so I have this counter, right, and a button. If I click the button, magically, this counter is updating. So what's going on here? Well, here's the code and markup. So this is a page, but a page is also a component. All right, so it inherits from component base. That's how you know. And essentially, we have this label here, or this output, this one-way binding of current count that we're mixing with some text here in this paragraph element. in the code block. And yes, you can move code to a class, but right out of the bat in the Razor page, you get this code element in every component, actually. We have this increment count, which updates the counter, and this @onClick. Now, the @ tells the system that this is a server-side call. There isn't any run @ equals server like you get with web pages, ASP.NET web forms. So that @ is the only difference between JavaScript onClick and Blazor onClick. So here's what happens. In the browser, we press that button. Now, how does the button know, right, that this is Blazor stuff? Well, turns out this page right here, _host.cs to HTML, this is sort of the starting point, the HTML starting point for everything, where you have your header and you have your body, and right down at the bottom, you have this blazor.server.js. So that is the JavaScript that hooks the DOM. And when you click that button, it says, this is a server-side call. So it packages up a binary message, sends it to the server over SignalR that says the user clicked this button, more or less. Server says, that's this method right here. It runs that method, and it knows that this current count has updated. It also notices that that affects the DOM. So to figure out what to send back to the browser, Blazor essentially has a graph of the client's DOM in memory. All right, so for every client, it has a graph of their document object model of this page. And when it executes this, afterwards, it gets a diff. It figures out what changed and packages up those changes in binary messages and sends them back to the browser. And the browser then, through SignalR, gets those messages and updates the DOM. So let's actually watch this happen in unfolding in real time here. I'm going to press F12, make sure that the cache is disabled, and start recording events here. And I'm just going to press Control F5 so I can basically load everything, for the first time again. And here's what we get. 165K transferred. That's not a lot. That's actually really, really efficient. All right. Now look at this. In the list of stuff, we got this _Blazor. All right. !ID equals blah, 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 some key. This is a WebSocket. So this is your SignalR traffic. If you click that, now you can see the messages, at least the size of the messages and the time, and whether they're going up to the server or coming down. BlazorPack is interestingly the name of the protocol that the Blazor team built to, the binary protocol to send these messages over SignalR, over SignalR. So I'm going to go ahead and clear this list, press the button again, and now let's go look at what just happened. So that JavaScript hooked the DOM, okay? And then it says, we got to call a server-side method, packages up a 291 byte message, very small, sends it to the server via SignalR. The server then realizes that it has to run increment count. So it does. And then it notices that there's a change to the DOM, and it sends it back. Now we've added some more messages. Ignore these. Sends it back down to the browser, 148 bytes. The browser then updates the DOM and sends back a everything's good message, acknowledgement, maybe the things that have changed. And there you go. So very, very, very efficient with bandwidth. Now, granted, it's just a counter, but compare this to, for you as the developer, compare it to the goo that you have to do in JavaScript just for the plumbing of getting to the component model, right? Here we've got the markup and the code together in the same page. Now, whether they were in the same page or we had a separate class, all of this could be packaged up in an assembly and shared, and you can make a NuGet package out of it. You can even add JavaScript to that NuGet package and then share it. And so this has opened up a whole new world of components and component vendors. Right? So DevExpress is one of those, Telerik is another one, but there are a whole bunch of component vendors that are now offering, you know, via NuGet package, these components that you can just instantiate and use. And the community at large too, the open source community, if you solve a problem, like I just solved a problem with playing audio files, like MP3 files, using JavaScript interop. I'm going to package all that up as a component and just share it as an open source package. It's very, very easy. All right, so let's get back to the model here. And we did this, we watched the traffic. Let's talk about scaling, because, so think about it. If your code is always running on the server, that takes the burden off of the client to sort of run any kind of code inside the browser or do anything special. But it also means that your server has to now be beefy enough to handle all the traffic and all the concurrent clients that you want in your application. So memory pressure is a real thing, and the amount of memory and CPU that you have is basically going to determine how many concurrent clients can comfortably access your page before it starts choking. Now, minimum, there's 85K of server memory required for every connection. So that's a minimum. That's without your data. So if you go to your database and pull down 1 million records and then populate a list of something, and then bind that list to, you know, a select or some other construct or a third-party controller, whatever, right? Now SignalR is sending down a whole bunch of data. That's one thing, but you have to keep that data in memory for every client who's accessing it. And that's going to limit the number of concurrent clients that you have. So this is just standard good web server, web app building practice. If you've built any applications on the web, you know that you need to conserve memory per user. And so it all applies right here. Just use your common sense in terms of paging, sorting, all of those tricks that you can use to limit the amount of data that the user sees at one point, just to their working set, just to the minimum that they need. Always be thinking about that. WebSockets are also a precious resource, and SignalR has a limit that is based on memory and CPU. So again, it all comes down to memory. Now, here's a cool thing. If you want to, you can scale out with this Azure SignalR service right here. And if you just follow this link or Google Bing it, Azure SignalR server-side Blazor samples, it'll show you how to use Azure SignalR service to completely remove that from your Blazor server application. So that's one way that you can take the burden off of your server just for SignalR. It also is a requirement if you're going to do a cluster, right? If you want to scale up, we're talking memory and CPU. If you want to scale out, now you know, multiple servers, now you have to move the state outside of your application, and SignalR is part of that. So, because you don't want to have different servers all listening to the same client, SignalR client. So you want to move SignalR outside. Now, I think we have some real numbers here, yes. So Microsoft did a test with Blazor Server to test for appropriate latency, meaning how many clients on a given configuration for a server, how many clients could they add clicking a button every second before the latency of, what happens when I get my results from that button click goes over 200 milliseconds. 200 milliseconds seems to be the tolerable limit or the threshold for what a user considers I made this action happen versus the computer is making this action happen. So the illusion of me making something happen happens at less than 200 milliseconds. Any more than that, and it's going to, people are going to get frustrated. It's going to be a problem. So this was a real application. This wasn't just a counter click. They did an application where they tested all of these clicks and the latency, and here's the results. With one CPU and 3.5 gigs of RAM, they could comfortably support 5,000 concurrent clients on one box, on that one box. That's without taking, using Azure SignalR service. This is just everything in the box, okay? So when they upped that to 4 CPUs and 14 gigs of RAM, they could comfortably support 20,000 concurrent clients, all getting less than 200 milliseconds latency, clicking once a second. So that's pretty good. Now, what it means is that if you have to determine whether, yeah, they are great numbers, but you have to determine if 20,000 is enough for you, and if you can afford that level of server on Azure, right? Or, if you're doing it on the Metal, that's another thing too. But you need to know if that's enough. And if it's not, now you have to talk about scaling out. And for that, we need to talk about state, which we will in just a minute. So let's talk about the benefits of the Blazor server model versus the WebAssembly model. And this is all in comparison to WebAssembly, right? Download size is significantly smaller. That just by just by the nature of using SignalR to handle all this code, you take away a lot of plumbing code on the client. So 165K just to load that counter is pretty small. Now, here's another big benefit of using Blazor Server over WebAssembly is that you're on the server. So you can do whatever you want. You have secrets in your config file that you can use to access databases, to access cloud services, storage, service bus, whatever it is that you want to access. You can do it all because you're on the server already. Now, opposite from that, if you're making a Blazor WebAssembly application, you have to build an API layer for everything, every bit of code that you don't want your user to possibly see. And yes, they could just, decompile those assemblies just like they could decompile JavaScript in a WebAssembly application. All right. So being on the server has its benefits, both in, the amount of complexity that I have to add just for basic stuff, and also development time. I don't have to build out this API layer. I don't have to build the API controllers. I don't have to design an API, right? I don't have to worry about throttling or any of the challenges that come with having an API. And I don't have to build a client-side service to access that API. Also, all browsers are supported. Now, Internet Explorer 11, it doesn't support WebAssembly because development on that stopped before WebAssembly was a thing. But so if you're using Internet Explorer 11, there is a polyfill that you need to support server-side Blazor, but it's very easy to install. So in other words, all browsers can take advantage of this, especially browsers with limited thin clients. So this is I put this last bullet up there because it is a benefit to some people, but I don't think it's that big a deal. If this was a WebAssembly app, we'd be shipping all the code to the browser, right, in the form of assemblies, which anybody can then decompile and look at the code. I was giving this talk in New York City, maybe where I picked up the coronavirus. I don't know, but I did have the coronavirus. I don't now. I'm tested. I'm clear. Second test was, we're good. But anyway, in New York City, in Times Square at Microsoft, gave this talk, and a guy from FinTech, from the financial technology sector, said, I don't want my clients seeing my code, right? And I said, well, but you had the same issue with JavaScript. He said, yeah, but I mean, we just run it in Node. Yeah, right, exactly. So in other words, UI code runs on the client in the browser, and anything that has secret sauce, even if it's calculations or stuff that you want to, not the user not to see, if it's secret algorithms, that kind of thing, yeah, you make an API for it, right? That's what you run in Node. So it's the same deal. I don't think it's that big a deal if you just follow the rules of the only thing that goes in Blazor in your components is UI code. Okay. So let's talk about the drawbacks. The downsides compared to WebAssembly, you have that added latency because of the signal RHOP. Right? Every UI interaction, goes back to the server for processing. Every interaction, like a button click or a list box selection or a checkbox, or if you're handling things on a keystroke, every keystroke goes back to the server. And so you have that added latency. So that means if your client's bandwidth is low, they're going to have an experience problem that you can't control, right? There's also no offline support whatsoever. So if the connection fails, the app stops working. And I mean, it stops working. And without proper error handling, they're going to think it just broke. And it did break, but they're going to think their browser's frozen or something. It's not a good thing. The scalability challenges are there. I just talked about that. And an ASP.NET Core server is required to serve the app. Okay, so whereas with a WebAssembly application, I can package everything up and I could distribute it with a CDN, and that would be fine. Because just for basic UI to happen, it doesn't, we don't need a server, but you do need a server for Blazor server. Okay, I'm just going to take a minute to answer any questions that you have about the architecture. I think I've pretty much covered everything there. Anybody? Questions? All good? All right. So I don't know if you want to see this. We don't really have time to cover the WebAssembly hosting model, but if you do the same thing that I did, which is open the network tools and watch the traffic, press Control F5, you'll see that you get, for that page, you get the default page, you get 6 megabytes of data transferred if the linker is off. In other words, if you're in release mode. And if you go in debug mode, if you go to release mode or you turn the linker on, it's only 2 megabytes overhead. But then you can actually see all the DLLs loading up in memory. So that's pretty cool. All right, let's talk about binding. So rather than read this slide to you, I'm just going to bring you over to the code again, and we're going to do some binding. Binding in the component model is so nice. If you've done any Angular or any other kind of JavaScript binding, even Knockout. It's funny, Steve Sanderson, who was sort of the driving force behind Blazor and the component model, is the guy who wrote Knockout.js. But so he's learned a lot in the and knows a lot about how binding works and what's good about it. So just check out how simple this is. First of all, we have an input here where we're doing a simple bind directive, and we're binding to this message right here. Essentially, at bind without a property that we're binding to binds to the default property of whatever this is, right? So this is an input tag. The default property is value. I could do this as well and specify the property explicitly, bind dash property name. It's the same thing. It does exactly the same thing. But since value is the default property, we'll just go with that. And so now what's going to happen is when there's an event that's defined by default that forces what's in here into the message, you know, the UI change. It forces the UI change, and the event is onChanged or onChange. And that happens by default when I tab off of the input tab, input element, or essentially lose focus. So when the input loses focus, I just press tab there. That's what forces the update to the message property. Now I can change that. I can change that. Let's change the event to a key press. We can do that with @bind::event equals, and then I'll say on input. All right. So now what this does is it says, instead of on change, every key press, I'm going to update message. All right. Now, watch this. Every key stroke goes back to server. Every keystroke, we're sending data up that SignalR chain. Okay, just be aware of that. Now, remember, SignalR can handle a lot of traffic. And based on those numbers that I showed you, that should be your guide, and the latency should be your guide, rather than, you know, oh my God, we're sending traffic back to SignalR on every keystroke. But anyway, there you go. All right, I'm going to add a component now. Now, in a Blazor project, you have a pages folder where all the pages go, and you have a shared folder. And I think this is misnamed. It should be components. All right, because the main layout, the nav menu, the survey prompt is actually a component, but main layout and nav menu aren't shared. They're essentially used in the application to divide up what you see on the screen. In the case of main layout, this is defining the sidebar, which has the nav menu right there. And then it has the main div that has a row across the top that shows the about, and then it has the body. So if you want to completely get rid of all this, you could just do something like this. All right, this is your main layout. Get rid of the nav menu altogether, and all of that, you know, Chrome with a little c for the Blazor looking application goes away. So now your Bootstrap stylus can go to town, and you're off to the races. The nav menu is the component that shows up on the left, and it has icons for home, counter, and fetch data. And we're using these nav links instead of just regular links because you can add all sorts of data to them. Okay, so anyway, I think this thing should be called components. So we're going to add a Razor component to it. I'm going to right click on the shared folder and say add Razor component. And this is called child component. Now here's an undocumented feature of the latest Visual Studio Preview. This has nothing to do with Blazor. It's like a preview version of Visual Studio. All right, so if you get that spinny stuff, just close the child component or whatever component it is and open it again. So here's the component code. All right, now this is just like a page, except we don't have that page directive, but it is inheriting from component base. Now, here's what I got. I have a div where some inline styling, I'm just padding it and setting the background color so we can differentiate it from the parent. I have a parent message that is essentially a property. And then when I click the button, I'm going to call update message. Now this property is a parameter, and parameters are the way that components can expose properties and events to the parent. Okay, so essentially this is like making a public method or a public property on a custom control. Look at the event definition. This is so beautiful. Event callback of whatever. So I want to define an event in my component where I can invoke it with, event name .invoke async and pass a parameter. Look how easy. Look how easy that is. I didn't need to create event args or anything like that. So from within the component, when we press this button, the component is going to change parent message, and then it will invoke this event. So how do we hook that in our parent page? Well, let's do this. We're going to instantiate the component simply by defining it, child component. All this other code is the same. And we're doing it with binding. We're not doing it with an event handler. I could have an event handler, and I could say, message changed equals, and then some, void message change handler that takes a string. I could do that, but I don't need to. Look at this. Child component. We're binding the parent message property. Remember, if you do a dash and the property name value, in this case, it's parent message, that defines which event we're binding to. So we're binding the child component's parent message to our message property. All right. So we got that two-way binding going there. And now we're saying that the event that changes, that forces the change from parent message to message, is message changed. That's the child component event. So when the child component event raises message change, guess what? Our message gets updated. Elegant, beautiful, a work of art. It really is wonderful. And the way that it works is just, genius. So on key press from parent. And now if I change it from inside the component, boom, it just ripples up everywhere that it's bound. I don't have any iNotify property changed. I don't have any of that. I just essentially raise an event from within the component, and it's just beautiful. This makes you so productive. I have never been more productive on a web development technology than I am with Blazor. And Blazor Server is sort of the epitome of productivity because you don't have the complexity of that added API layer. So this should be really good news for you. All right, so that's just the reference of what I talked about. Now let's talk about state. State is everything in a Blazor application. Where that state resides determines a lot of things. You can't scale out without moving state outside your application. And just in the interest of time, we're going to go right into another demo here. Look at the counter. I've got this current count here defined on the page. And what happens to that variable? When does it change? Well, it changes when I update, right? But if I navigate away, if I navigate home and back to the counter, it goes back to 0. Why is that? Well, it turns out that all components reinitialize on navigation. And so there's a bunch of virtual methods that you can override. To keep it simple, on parameters set happens before rendering, and on after render happens after. Those are really the only two that you need to worry about, but you can see protected override void on parameters set. This, you should get in the habit of this being your, your load. Okay. Actually, watch this. Watch what happens. Every time I go to the counter page, that should fire. There it is. And when I click the button, it doesn't fire because we're still on that page. But if I navigate away and I come back, it's going to happen again. All right. So on initialized happens first, then on parameters set, then on after render. But that's not why. I just wanted to show you that we were reinitializing everything. So the first step is to move all of the data that you're accessing on a page into something that doesn't exist in the page itself. So let's start with a class. Let's add a class here. And I'm going to call it app state. Now you can call it whatever you want. But if you're coming from a ASP.NET Web Forms background, this is like you're going to be your session object. All right. Now you can have multiple session things if you want, right? Multiple states for multiple pages, whatever. But we're just calling this app state. We're putting it all in one. And I'll make a single property called counter. Okay, so that counter is what going to take the place of this guy right here. Now, how do we get it in here? Well, I can't just instantiate it because it'll go away when I'm done with the page, right? What I want to do is create a scoped service. So I'm in startup and I'll type services.add scoped app state. Now here's the deal. On Blazor server, you have the idea of singletons and scoped. And the difference is that a singleton has one instance of whatever this class is that is shared among all clients. Okay. Scoped, we get one instance per client. So every client gets their own instance of app state. That's what scoped means. All right. That's what these things do. Weather forecast service can be a singleton because there's nothing critical that it needs to store for each client in there. But anything that's sort of like that session, going to be the session state, make it a scoped variable. Now, how do we get that into counter? We inject it. Just like this, inject app state, app state. All right. So that doesn't instantiate it. That takes whatever this instance is, however it's scoped, singleton or scoped, and we have access to it. So if we did this in the index page or in the fetch data page, it would be the same instance. So now we can replace current count. We can get rid of that altogether. And we can replace current count with app state counter. Now that the state of this page lives in a scoped service, I don't have to worry about it reinitializing on navigation. Right, there's 5. Here's my home. Here's my fetch data, back to counter. Hey, guess what? It's still 5. All right, that's step 1. Now, step 2, we have to talk about, because if you're scaling out, right, this is where step 2 makes a lot of sense, is persistence. How do we persist that state? Because right now, if I press F5 and run the app again, counter goes back to 0. But what if I have something, that I need to persist between requests? Well, there's a couple options. One option is using local storage. So local storage is good for small amounts of data, but not big amounts. Why? For the same reason that ViewState sucks, right? ViewState and ASP.NET Web Forms means that the state of the DOM, of the UI, travels back and forth over the connection with every request. Well, it's not going to be quite that bad, but what happens is when you go load the state from local storage, right, you have a request going to the browser to pull up the local storage data, and then that goes back over SignalR, just the data itself over SignalR, gets rehydrated, and then when you bind it to your lists or your objects or whatever it is, all of those DOM updates go back to the client. So there's that round trip happening again, just kind of like ViewState. So the guidance is, for a couple of K worth of data, it's fine. Don't worry about it. But for any more than that, you want to think about a database or a data store. Now, what kinds of databases? Well, certainly not relational databases. You need a name value pair kind of database, a document database, MongoDB, RavenDB, something like that. They're cheap, right? You can run them in a container. Very easy to access. Definitely not Cosmos DB, very expensive. And again, you don't need the relation stuff. Just a document store is good enough. If you want to create your own store just on a separate server for name value pairs, you pass in a key, which is the user ID, a GUID, and then you get back the state, or maybe it's a key and the page and then the state, or you have a name for it, whatever it is. So I'm going to show you the local storage example of storing state. And this is on my blog, blog.appvnext.com, our blog. It's a shopping cart idea. And so these are some items that you can add to your cart, some coffee beans, and I'll take two bags of those. And now my cart shows here what I have in it. I've got some beans and quantity 2 and a nice total there. And I'll add a Tablet Show coffee mug, a coveted Tablet Show coffee mug. And now I'll exit the application and I'll run it again. And if I run it within 30 seconds, that's just the default, all of that state comes back. Okay? So here's how I do this. And this is all adapted from code that Steve Sanderson shows on his blog. And he did it with the counter. And I essentially updated it to use a, oh, somebody said Cosmos DB has a pretty generous free tier now. Oh, that's interesting. Still, it's a little bit overkill for what you want to do. All right, so here we go. We have 3 models. We start with a product, which just has, you know, a name, a description, and a price. And then we go to cart product, which adds a quantity and gives us a total, right? A product and a quantity gives us a total. And then we have the cart, which is a list of cart products, right, with a totaler. But it also has these things: last accessed, which is when was the last time we touched this, and then the time to live in seconds. By default, it's 30 seconds. And I only set it to 30 because it's easy to demo. And what I didn't demo is if you wait after 30 seconds and run it again, the data's gone. Okay? So here's how it works. We have got a component, a shared component called cart state provider. Now, if you look at the packages that I'm using Microsoft ASP.NET Core protected browser storage. This is a way that you can use session storage and local storage, both of which are browser-based guys. so I'm using that. I'm injecting that in because I've set that as a service that I'm using, protected browser storage. So I'm injecting that in. And I have my child content, which is a render fragment. And I've got a public shopping cart. And here's my on parameters set, which is the initialization of the component, right? I'm retrieving the shopping cart from local storage. It's called my shopping cart. Name value pair, right? And if it's either null or I have nothing in it, I'll create a new cart. Otherwise, I'm going to check to see if the cart has expired. And if it has expired, I'll create a new cart. And I'm going to set the last access to data time now, and then load it up. Now, when I save it, I basically set the last accessed, and I call set async my shopping cart and shopping cart. Just save it to local storage. That's what I'm doing. So how do we call this? Well, take a look at the index page. So here's the link to Steve Sanderson's demo. And we're going to display a list of products. I have in my code here, list of product, all products, and then I have a selected product. So here's a select statement, a select element, essentially, with an onChange, which happens when I click something. I'm going to just select the products there. When I click product selected, it's going to pull it out of all products with a little link. And I have this show item equals true. Now, if the selected product is not null and show item equals true, just a little table to show the item. And then there's in here an add to cart button, right? Which I have the quantity, the selected product, and when I add to cart, whoops, let's just run this, or not run it, but go to add to cart. Now I'm creating a new cart product, saving it to the shopping cart, saving the changes, show item equals false. That means I'm not going to display it anymore. Now, if the cart state provider is not null and the shopping cart items count is greater than 0, I'm going to say your cart and show it right here. But here's the deal. There's my product selected on initialized, which happens before on parameters set. Doesn't matter. You can use either one in this case, but I would prefer that you use on parameters set because that is the last thing that happens before rendering. You create the products. We're adding products to it, right? So there's all products. And we have this cascading parameter cart state provider. And that's exactly what we use for this. So a good demo of how to, ooh, that was nice. How about this? Nice. All right. So that was a good demo of how to use local storage. Now that is pretty much all I have, except I want to show you one more thing. And that is code behind. This is something that you can do with anything. I will go back to my Blazor server application and we'll go to our counter, which has some code here. Now, granted, it's only increment count. But if I wanted to move that to a class, what I would do is on the pages, I would add a new class that has the same name, counter.razor.cs. All right, so it has the same name as my component with a CS extension. And now I have to make this a partial class. And I have to inherit from component base. And now I can move my code in here from counter. Just take that like so. Now, the only difference is I need to make my methods and any variables that I want to access protected. And that's it. That's code behind. It's pretty simple. And I'll just run this one last time so that you can see what's going on. There it is, seems to be working. And of course, if I come home and then go back to the counter, it's still there. All right, so ladies and gentlemen, that is it for me. Sort of right on time at 11 o'clock. I will stick around for any questions that you want to ask. If you want to ask them here, you want to ask them in the Slack channel. Either way, go ahead and otherwise, have a nice day.
Hey, y'all. I am so excited to be joining you from the US and to be helping close out this amazing NDC Porto conference. And thank you for joining my session. I hope you're doing well and staying safe. Hello, I'm in recovery for type coercion and automatic semicolon insertion, and my name is David. Maybe you're like me and you've been burned a time or two by JavaScript, burned in development and in production. Well, JavaScript has caused many a developer more than a fair share of indigestion over the years. My first introduction to JavaScript was around 1997. At that time, I was a Visual Basic developer, and I started building web apps with ASP, active server pages, what we would now refer to as classic ASP. And I kept reading about people doing this thing called dynamic HTML. And I wanted to learn how to make my websites more dynamic. Dynamic cursors, alert boxes, rollover buttons, objects that bounce around on the screen. The more obnoxious, the better. Am I right? Well, my career really started to take off and get serious as a web developer around the .com bomb in the early 2000s. I joined a hot startup to build an interactive commercial web app, and I needed to support both Internet Explorer and Netscape. It seemed like so many cool companies were having great success with JavaScript. I wanted to be a cool developer, but it sure was a struggle to learn, and there was a lot of trial and error. With JavaScript, anything goes, and it often does. If you were a web developer around this time, you probably remember sites like Dynamic Drive. I spent countless hours trying to understand the JavaScript code I lifted from sites like Dynamic Drive, and it worked on their websites, the examples and everything, but when I pasted the exact same code into my app, it didn't work, and I couldn't figure out why. JavaScript is amazing, except when it isn't. There's quirks and weirdness in the JavaScript language that continue to exist even to this day. Unexpected behavior can baffle even the most seasoned JavaScript developer. Let's take a look at a few of those examples of that quirky behavior. JavaScript has this special value named NaN, N-A-N, which stands for not a number, which is not to be confused with null or undefined. So given this statement, if the variable f is not a number, is NaN, then the entire operation of the result will be NaN, which can lead to lots of fun time. Sometimes it's very difficult to find where the NaN is occurring in your code. And it's, maybe you're looking for some clues. So how can we test in our code for NaN? It's not a number, but what's the underlying value of NaN? What can we test for? Is NaN greater than or equal to 0? No. Is it less than or equal to 0? No. What's the type of the NaN object? It's a number. Gee, thanks a lot, JavaScript, for making our lives so easy to use this tool. In math, we have something we call commutative properties. So mathematically true, if we take A plus B and, these are equal statements, right? Order of operations and everything. In JavaScript, when we evaluate this type of statement, it's not always predictable. There's cases where it's true and there's cases where it can be false. So if we were to say, is this code true or false? No, it doesn't always equal true. If we try to look at, is 0.1 plus 0.2 equal to 0.3? No, it's not. What? What is 0.1 plus 0.2 in JavaScript? It's 0.3 something. This is not just a JavaScript problem. This is floating math, floating point math, and for computers is hard, apparently. Seems like we're smart people. We should be able to figure these things out. But this is the kind of stuff that we still have to deal with. Here's an example. If we round this gigantic number, we get 0, as we would expect. It's less than 0.5, so it's going to round down to 0. However, if we round this very long number, and if you notice, the only thing that changes between the two numbers is the very last place, from 2 to 3. If we round this number in JavaScript, we get 1. Fantastic. I've got 99 problems, but JavaScript ain't 1.00000000009. Let's talk about sorting in JavaScript. If we were to sort this array of 2 and 10, we would get 10 and 2 as we would expect, because JavaScript is being really helpful in ignoring the fact that these are numbers, not instead of strings. If we map things like an array of strings and we want to parse these numbers, we would expect an array of 10s, right? No, we get something silly like this. Thanks, JavaScript. And then, there are types inside JavaScript. And there's this type of operator that helps us to determine what these types are. So if we say, what's the type of undefined? It's undefined. Type of true, that's a Boolean. Type of string, it's a string. So far, so good. Type of 1 is a number. But if we say type of an object, well, it's an object. That's great. If we say type of an array, it's an object. Type of null, it's an object. The black art of figuring out the type of variables, I don't know. Good luck. And then we've got things like, we've got this helpful operator called number. Number is supposed to convert things over to the numeric values of these things. So if we take null and pass it to number, on the other end we get 0. So null must be 0, right? It must be equal to 0. No. No. Is null greater than 0? No. Is null less than 0? No. Is null greater than or equal to 0? This one is true. I have no idea. Less than or equal to 0 is true as well. It's not 0, but it's somewhere. I don't know. And then we've got these weird concepts in the JavaScript language like falsy, truthy, and falsy values. False, null is considered to be a falsy value. Undefined is falsy. Empty string can be equal to false. 0 is false. Nan can be false. Yeah, good luck. And then there's things like, powerful features in the JavaScript language like regular expressions. I have a problem, I'll solve it with a regular expression. Now I've got NaN problems. So we take something like this, we have WAT equal to this regular expression of A. We want to test the string JavaScript, and yes, there is an A in JavaScript. And then we test, we turn around and we test another string, and that's false. What? Well, it turns out that the regular expression object itself maintains state, and so the index changed out from underneath us. That's can be really helpful and easy to figure out. And then we got some syntax quirks, like, we've got this function. We want to return an object. And what should this troll return when we call this function? It returns undefined. What? I thought we were returning an object. Well, JavaScript tries to be really helpful, and there's no, syntax matters. And so it sees this return statement with nothing else after it and thinks, oh, well, I need to insert a semicolon here. Thanks, JavaScript. Let's talk about arrays. Arrays are dynamic in JavaScript. That's pretty cool. You can just start stuffing things into arrays. Like if we want to index 1 and change that value to 1, or index 3 and get that a value of 2, we can willy-nilly add things to an array. And when we're done, we can take array.length to figure out how many items are in our array. And we get 11 items in our array. This almost makes sense, right? Maybe. Well, we can do some weird things with arrays too. We can index -1. We can say array.s. We can start just willy-nilly adding properties to our array. And when we take array.length, now what's our length now? It's still 11. Why? JavaScript has been around for years, and we're smart people, right? Why haven't we fixed these things? How did this happen? JavaScript, arguably the most popular, most ubiquitous, most universal, most pervasive language in computer science history so far. If it's so important, why is it so terrible at times? Well, let's look back at the birth of JavaScript. It's a classic example of how so many things get created in software. And it's funny, but it's the kind of funny that makes you want to cry. This is Marc Andreessen. He was at the University of Illinois and was one of the people who created the very first internet browser, the NCSA Mosaic. Marc later moved to Silicon Valley, and he helped start a little company named Netscape. In February of 1995, Marc hires a man named Brandon Eich. Brandon was hired to create a scripting language for Netscape. The original plan was to implement Scheme, a dialect of Lisp. In May of 1995, Andreessen calls in Brendan and says, "Brendlepants, we need a demo of that new scripting language, like yesterday." "It's Brendan, sir. Sure thing. Scheme in Netscape is going to be awesome." Brandy Forums, you're hilarious. Scheme in the browser. Oh, man, you got me going there. But seriously, though, it's got to look like Java. Let's call it Mocha. Mocha, Java, get it? And we need a demo by the end of next week. People aren't convinced that this thing is going to fly. I'm going to need you to come in on Saturday, okay? And Sunday, too. So, what does Brendan do? He does what any of us would do in this situation. He works like a heroic machine through the nights, and 10 whole days later, he delivers Mocha. The first version of JavaScript was created in 10 days. That's both incredibly amazing and absolutely horrifying. Good work, Boogaloo. Ship it. But sir, it's only a demo. I still need to ship it. It's the most classic move in all programming. Ship it. Mocha was supposed to be for amateurs and designers anyway. Who cares if it's buggy? The real professionals are going to use Java. Java is the future. Plot twist. Java. It was supposed to be the language for the web, for the browser. And we know how that played out. Java, the applets, remember, write once, fail everywhere. Well, I think it's interesting to look at some of the other things on the timeline during the early days of JavaScript. After Mocha is created in 10 days, it goes through a couple of iterations. The code itself doesn't really change, but it goes through a couple of names. It got renamed to LiveScript for a little while, and then JavaScript in December of 95, Netscape releases, I think it was version 2, beta 1 or something like that, that includes JavaScript. Well, Microsoft takes notice, and they see this cool new scripting language that's in Netscape, and they decide to reverse engineer what Netscape has done. But if you remember this, if you were around this time, they didn't call it JavaScript. JavaScript is trademarked by Sun, so they called theirs JScript. Well, Microsoft did such a good job of reverse engineering that they reverse engineered everything down to the littlest detail, including all the quirks and things that JavaScript did weird. Now, this prompted Netscape to go on the defense. So Netscape is seeing how Microsoft worked, at least around this time in history. Microsoft's classic strategy of embracing, extending, and extinguishing technology, right? Netscape knows if Microsoft has their way, they'll run away with the language and ultimately destroy it or replace it with something else, or who knows how that may have turned out. So in an offensive move against Microsoft, Netscape decides to standardize the JavaScript language. So they went and talked to the obvious candidate for the standardization, the W3C. And the W3C responds with, oh, well, no thanks. We have more important things to focus on, like marquee and the blink tag. Well, thanks, W3C. Keep up the good work. We'll move on. So Netscape approaches ECMA International, which is a standards-based organization in Sweden. And ECMA takes on the project, and they form what's called the TC39. This is the Technical Steering Committee for the JavaScript language. And eventually, after a little while of work, the TC39 creates a document called ECMA 262. ECMA 262 is what we have. It's what continues to evolve to this day. It is the formal language spec for the JavaScript language. Now, the reason it's called ECMA, and we hear this strange word used a lot. JavaScript, again, at this time, and still is to this day, although it's arguably unenforceable, JavaScript is a trademark of Sun, and they couldn't use JavaScript as the name of the language in the spec. So they named it ECMAScript. This is where ECMAScript comes from. ECMAScript is the language specification. JavaScript, as we find in the browsers, is just one of several implementations of that standard. So you know, fast forward a little bit, ECMA releases ES2 in 1998. It's basically just some updates for ISO certification. And then we get ES3 in 99, which includes some things like regex, try-catch, and some better string handling. Now, moving forward in time, we look at ES5, adds strict mode and reduces some of the quirkiness of the language. There's JSON library support added. And ES6 is a major update, adding classes and generators and arrow functions, promises, and many more features. But wait, hang on a second. What the crap? 10 years between ES3 and ES5? Man, if you were a web developer during these years, that's a long time to wait. And it was a real struggle, right, to build web applications using ES3 until ES5 came along. So what happened here? Well, Microsoft won the first browser wars with IE6 around 2001, and basically they sat back to watch the world burn. Microsoft won, but we as web developers lost. By 2008, now, ES4 was being worked on, and by 2008, ES4 was so big and so complex, and there was no consensus among the members of the standards committee, and for technical and political reasons, there was representatives from Microsoft and Yahoo and Adobe that were all part of the committee. So an important decision was made to abandon ES4, and they took some incremental changes that was slated for ES 3.1 and renamed it to ES5 and set the path forward. Well, there's an interesting side note here. If you remember during those days, Macromedia Flash was a plugin that once dominated the web. People created amazing interactive interfaces and games with this animation plugin. What you couldn't do with JavaScript, you solved with Flash. In Flash, if you were building anything more than maybe a cartoon, you needed to use its programming language called ActionScript, which looked a lot like JavaScript. That's because ActionScript was another implementation of the ECMAScript standard. So between 1999 and 2009, the developers at Flash were early implementers and adopters of the proposed ES4 spec, and they were helping to push the language forward. By 2006, ActionScript 3 had classes and interfaces. It had a type system. There were enums, default function parameters, modules, packages. It had a lot of great language features. Flash developers could argue that what they had in 2006 is still better than what we have in JavaScript today. Let's take a quick look at a few other major milestones of the web that helped to influence JavaScript over the years. In 2001, we talked about Internet Explorer 6 coming out, and that helped or hurt in some cases, set the JavaScript language for a long time. But around 2004, we see some tools like Firefox comes out, and there's a web developer tools that gets created for the Firefox browser, and Gmail comes out. Gmail, along with Google Maps, and, took the browser apps to a whole new level, never thought possible. And they demonstrated to the world what the browser was capable of. And jQuery made a huge impact on web developers because it was for the, it wasn't the only library that did this, but this is, jQuery really took off in popularity. but it was, jQuery gave us a single API that normalized the differences between the browsers. jQuery and its popular plugin community made web application development accessible, taking away a lot of pain. Not all of the pain, but a lot of it. But web apps could be built by mere mortals like you and me with the help of jQuery. And then around 2008, Google Chrome comes along and it takes the web by storm. Microsoft has been coasting on IE6 for years, and people are desperate for a better browser. The Chrome adoption grows so quickly that it stirs Microsoft to start releasing new versions of IE. And in 2009, we get the ES5 Harmony, and around this time, Internet Explorer 8 comes out. And then, just for reference, there is a 15-year gap between HTML 4.1, CSS2, and then the release of HTML5. But that's a whole nother story. Let's go back to the TC39. There's 10 years between ES3 to ES5. And then there's another 6 years from ES5 to ES6. The TC39 knew that they needed to fix their process. But adding new features to the JavaScript language is not a trivial task. The first rule of the TC39 Fight Club is don't break the internet. Backwards compatibility has always been one of the highest priorities when making changes to the language, which is why some of the quirky behavior still exists. It continues to exist on purpose. It's codified in the spec because if they fixed it, it would break code all over the world that expects that weird, quirky behavior. The internet would collapse and the world would explode. I submit my hypothesis that the Death Star superweapon is actually a very powerful JavaScript emitter. I think that's right. The TC39 committee is made up of developers, implementers, framework authors, and academics. The ECMA 262 document is currently more than 1,200 pages. Since 2015, the TC39 has been on a better process, has had a better process in place, and they do things like they meet every 2 months, they meet for 3 days at a time, the discussions are time boxed, the entire process is open, and you can follow their progress through their repos and meeting notes. So everything's done out in the open. In order for a new idea for the JavaScript language to make it into the ECMAScript standard, that idea has to be moved through a series of stages. Stage 0 is the first stage, and of course, the TC39 process is a zero-based index. Bunch of nerds. Stage 0 is the idea stage, also known as the straw man stage. Lots of new ideas get submitted at stage 0. And then stage 1 is the proposal stage. There's an agreed upon first draft of this idea. A proposal essentially states what the problem is, how it might be solved, and some of the known technical challenges. A polyfill might be created as a proof of concept. And a polyfill is like a JavaScript library that demonstrates how this new idea might behave or look. At this time, a champion on the TC39 is selected to take ownership and to see this proposal through the rest of the stages. In stage 2, this is the formal spec stage. A specification draft is created. The syntax and semantics and backwards compatibility, all that, those kinds of details are fleshed out as part of the idea. And then stage 3 is called the candidate stage. The specification has been finished, and this is a signal to the rest of the world that they can start, trying to implement this new change in the specification and get real world usage and feedback. So at this time, browsers and other implementations of JavaScript or ECMAScript can choose to add this new feature. Usually it's behind a feature flag or a plugin or something like that so that people can test it. And this is where we see Chrome add new features to V8, which is the Chrome JavaScript engine, behind feature flags. You can turn those on or off. And in Node.js, which also uses Chrome V8 as its engine, those feature flags can be used like command line switches. Now, when something reaches stage 3, it's very close to being in the spec, but it's still no guarantee that this is going to make it into the final standard. There's enough feedback. If there's enough feedback that comes back to say this, this is not ready for production, this is not ready for the real world, then some proposals may never reach the next stage, or they may stay in that stage for a long time until it's finished. So when something gets to stage 4, it is finished. There are acceptance tests that are added to another project called Test 262, and there has to be at least 2 implementations that pass these acceptance tests. It's ready for the next release of the language spec, and a PR is created for the ECMA 262 document. Now, the cadence that the TC39 has been on since 2015 is the stage 4 candidates or selections are made in January of that year, and the new edition of the ECMA 262 document is released in June. And that means that we will soon have ES 2020. We've had ES 2015, 2016, 2017, 2018, 2019, and now we're at 2020. The decisions for ES 2020 have been made, and the latest features have made it to stage 4. Some are already available. The 2020 spec will be published in a couple of months. And if you're interested in knowing, there are several new features worth looking at. One is optional chaining. This is how this feature allows us to safely access deeply nested properties in a JavaScript object. So imagine you have a JavaScript object like this one, and the address, some of the properties on the address, or maybe the address itself, is optional. Of course, everything in JavaScript is optional, but you know what I'm saying. In the past, to access a property deep in the object, such as the city, you would have to test every property along the way to make sure it wasn't null or undefined. So optional chaining can express in one statement how to get access to an optional property, so that we don't have to test every single parent along the way. There's a new feature called nullish coalescing that allows you to test values that are specifically null or undefined. In the past, we've had this using the 2 pipes. We can say, is this thing falsy or not? And if anything that can be false, null, undefined, empty strings, 0, all those kinds of things, then you would get the default value. But if you only want to test null and undefined, you can now use double question marks to test for specifically null or undefined. One thing to note, if you're a Node.js developer, Node.js 14 was just released this past week, and it includes optional chaining and nullish coalescing because those are available in the newer versions of Chrome V8 JavaScript engine, which is what, as I mentioned before, it's what Node.js uses. There's also a global this, which is a consistent way of accessing the global object, regardless of your environment. So in the browser, there's the window object. In a web worker, there's the self object. And in Node.js, there's the global object. So now global this gives you one thing that you can use in case your modules or code is going to be used across multiple environments. There's a new promise.all settled, which is similar to promise.all, which we've had in the past. It takes an array of promises and it resolves when all those promises have finished. However, when using promise.all, if one of those promises is rejected, then it returns immediately and it's over. Promise.all settled waits until all the promises have returned, regardless if they are resolved or rejected. There's a new feature called dynamic imports, which allows us to dynamically import modules, and that import syntax is a promise that we can use either the promise syntax or use async and await. So in the second example here, we had a button listener click event, which means that that module, reporter.js, is only going to get loaded if someone clicks on the button for it. There's also a match all for regular expressions. Now, I can't go into the details for the sake of time, but trust me, this one statement, this one line, is saving a ton of code that you would have to do in order to do what this new match all function does now. And then there's a new data type called big int. And in the past, the largest integer value you could have in JavaScript was 2 to the 53rd power minus 1. That's a really big number, but it turns out we sometimes need numbers bigger than that. And so big int is now a native feature of the JavaScript language that allows us to deal with bigger integers, any really arbitrarily large integer. There's two ways to declare big ints. You can use the big int constructor, or you can use the letter n on the end of a number to signal to the JavaScript compiler or engine that this number is a big int value. Okay. Despite the weirdness and the warts of JavaScript, there are amazing things that continue to be created with the language. I mentioned this earlier, but applications like Google, Gmail, Google Maps, Google Sheets, these changed the landscape for web developers and help us to realize what we could do with the browsers and the JavaScript language. NASA is using Node.js to help analyze spacesuit data and to make astronauts more safe. JavaScript making astronauts more safe. It's a bold move, I have to admit, but that's what's being done. Atwood's law states that any application that can be written in JavaScript will eventually be written in JavaScript. And this self-fulfilling prophecy is no more true than things like emulators. There are entire operating systems that have been created using pure JavaScript. There's a DOS implementation, there's a Linux implementation, there's a Commodore 64 emulator, and God help us, there's Windows 95. There are so many things you can do with JavaScript, whether you need to or not. And there's things like Internet of Things with libraries like Johnny5 and Node-RED You can do music using a tool like band.js. I have a personal project called Charter that takes chord charts in Chord Pro text format and turns them into beautifully formatted PDFs. JavaScript works great for doing things like that. There's games, and then there's desktop apps like Visual Studio Code, GitHub Desktop, and the Slack desktop app. Those are all examples of apps created with Electron, which is essentially Node.js and Chromium for the rendering. And that only just scratches the surface of what you can do with JavaScript. You can build really anything that you can think of that you can build with JavaScript, or build with a programming language. You could probably build it with JavaScript. May not always be the best choice for a given thing, but you can do it, and the power is there. JavaScript can be challenging, but it's getting better all the time. And I think the JavaScript language that we have today is far, far better than what we had years ago when we went through those years of ES3. And I find that JavaScript is now a joy to work with most of the time. Now, here are some of my thoughts on the future of JavaScript. In the life of JavaScript so far, we've seen the language evolve and be influenced by a number of other languages and libraries, browsers, and technologies. And in the past couple of years, TypeScript has gained a lot of momentum. TypeScript does seem to be becoming the standard for a type system for JavaScript. If you listen to the TypeScript believers, you might be convinced that it solves all the problems in JavaScript. I wouldn't go that far. Eric Elliott, a well-known author, speaker, and open source developer in the JavaScript community, he wrote an article called The TypeScript Tax. It's a cost-benefit analysis of using TypeScript based on his experience. Now, his experience can be different from other people's experience and is different. So it's the scenario of, well, it depends, right? But Eric Elliott makes the case that contrary to a lot of hype out there, TypeScript projects can introduce more friction instead of less friction. It can introduce more time, it can take more time to onboard new developers, and argues that a type system for JavaScript will only prevent a small percentage of bugs. The bigger, more costly bugs can't be prevented by a type system. It turns out, if you think about it, any language, a language that's dynamic or a language that's static, it doesn't matter, can't save you from making mistakes. I recently had a conversation with a developer who said 2 years of using TypeScript that he wishes his development team could go back to using plain JavaScript. So I've heard lots and lots of stories from both sides of the spectrum. TypeScript is great, can do a lot of great things. It can help you to move faster. It can help with large scale projects. It can help you to reduce friction when refactoring code, or it can also increase friction and cause frustration. It could be, just like the JavaScript language itself. Some of those things can be solved by education and experience and disciplines. Well, regardless, there are some benefits to TypeScript, and I see that TypeScript is continuing to have impact on the web developer community. I find it interesting that there are members of the TC39 who use TypeScript. And my prediction is that we may start to see the most valuable ideas in TypeScript begin to make their way into ECMAScript. And if that happens, will there continue to be a strong case for TypeScript? I look forward to a day when maybe we no longer need to use a tool like TypeScript. We have everything that we need in the Java, the pure JavaScript language. Regardless, I believe that there is a strong case for investing in JavaScript. The good, the power, the flexibility, the universality, it's everywhere. Those things, in my mind, far outweigh the negatives. The language, as I mentioned before, has improved tremendously in recent years, and I believe it's only going to get better. Thank you, JavaScript, for enriching our lives, for keeping us on our toes, and for making us humble when we're tempted to believe that we have it all figured out. I believe that all of us in technology have an incredible opportunity and a responsibility to make a positive impact on our workplaces, our community, and the world. I challenge you to take the things that you've been learning at NDC Porto, you share your experiences with others, and you help make our world a better place for everyone. Wherever you are, I hope you stay safe. You cherish the time that you have with your loved ones. You make the most of the gifts and the talents that you are blessed with, and you get out there and you be awesome. If you have any questions, please ask me on Slack, and I will answer them the best I can. Thanks, everyone, and I hope you have a great rest of your day.